Alrighty, we are going live. Here we are. I am with Jerry, and we are going to be going over Master Keying Advanced today. So we did do the first one. There is a link in the chat or comment section. You can also email me. You can email me at tricountylocksmithservice@gmail.com if you need that link to the basics class. The basics class, we just basically covered the ideas and concepts behind master keying, how it works, how to make two keys work in one cylinder, some basic two-step pinning, and how to start designing your program. Tell us a little bit more about the basic class that we did there, Jerry. Turn your mic on and you'll be good to go.
Basically, we went through the shall I say, the learning steps of how to do a two-step master key system. Basically, a change key and the TMK, and just going along, and the basic stuff is basically covered in there.
Beautiful. Yep. So we will put a link over to that as well. That class was free as well. And so we're just trying to bring good quality content and information. And if you're wondering how we got to this position, Jerry had reached out to me on Messenger and said that he had this system, and I was looking at it and it looked really cool. And it looked like he has a little bit different way to get more change keys out of your conventional system. So the more we were talking about it, I was like, well, it would be really good. I think people really want to understand master keying better. We want to take over existing systems that aren't being maintained very well, because we all know those systems that are out there where you go to a job and the master key doesn't work on some locks. There's been random locksmiths that have been called to come out and rekey that system, but the end user didn't know that they were on a master key system. And there's a lot of mystery behind it, like how these systems start to get destroyed, how ghost keys start getting made, how things just get taken off of the master key system, and then how do we put all that back together? Like, how do we get organized again, and how do we really start from the beginning? How do we decode the system? How do we understand what is supposed to be in place there, and how do we get that system back online? And that's what Jerry's method here really shows us. And so I thought that would be a very useful piece of information for people to have. And that's where we came up with this. And then he also has the 70 system, which basically takes a Russwin Corbin system and allows a whole lot more change keys and a whole lot more changes through the typical Schlage system by utilizing specific pinning and cuts that are not typical Schlage cuts. Tell us a little bit more about that, Jerry, and how you came up with that Schlage 70 system and how it's utilized.
Wayne, it can be Schlage, Arrow, and Sargent as well. Basically, you use every other pin depth, and you do not use the standard 2, 3, 4, 5, 6, 7 master pins. You use we'll see it in the video or in the class, how it all comes about and how it all works properly, so that you can get, instead of 4,096 changes, you can get up to 15,625, but you have to account for max. And max is the rule, max is the king. And when I say max, I mean maximum adjacent cut specifications.
Right. Yeah. And so based off of those rules, that's the number one thing that we have to separate here is we're going to go over the advanced two-step system, and we're going to show that. And I actually got some really cool cutaway cylinders. There's a gentleman online that posts a bunch of stuff on Instagram, and he's very, very in tune with his machining equipment and his little machining equipment, and actually cutting away these cylinders to the point he's got some new math figured out to where we've seen typical cutaway cylinders and it just has the top chambers so you can barely see the pin, the top pin, and sometimes the bottom pin. I've got a couple of them back here, but he has it to where there is a gigantic window to where we can see all of those individual master pins working in the individual keys. And it just really shows a nice visual demonstration. And that's what we've got involved with this as well, too. So I wanted to add a huge, nice visual compensation to this. All 4K video zoomed up. The cameras now are just ridiculous. So you're going to see things in a new light. You're going to be able to see it on paper. And then for learning purposes, I like to have things that I can see visually and see it on paper. Then we can write it out, and then we can actually see how it's working and what's happening inside that cylinder. Because before, you couldn't really see what was going on in there. You would just kind of have to guess and understand based off of what you can see in your hand. But now you'll be able to really get a good visual as to how that works. And we'll have that for the two-step system. We've got just a little basic Kwikset rekey as well, where this is real world application. We'll kind of go back and remind ourselves, what are we actually doing here and how do we apply this to the real world? And that is, hey, I've got a customer that says, I want these 3 locks to all work with their own key. And then I want this one that's an owner's closet to unlock those 3 locks. And that needs to unlock itself. But those 3 lock keys all need to be keyed alike, but those keys can't work on the owner's closet. Like this is, and getting that information out is actually half of the job, to be quite honest. There was a little bit of a language barrier, and it took about 15 to 20 minutes to actually decipher, what do you want here? At the end of the day, you want this key to work all of the locks, and you want these keys to work these 3 locks, but these keys not to work the owner's closet lock. And when you start breaking it down into security and start trying to understand exactly what the end goal is, obviously what we're doing here is they want cleaning staff, they want property managers to have access to these 3 closets, but they do not want them to have access to the owner's closet. So when the owner comes, they can put their high-end valuables, alcohol, whatever they're going to put in there into that one unit, and they're going to keep that key and not allow cleaning staff and property managers to have access to that one room, but they want them to have access to the other room to make sure that the tenants stay out of there as well. And that's the whole point. We want to keep the tenants out of certain places. We want to allow property management and cleaning services to certain places, and we want to keep everybody out of another place. So breaking that all down and really helping your customer understand, or having your customer help you understand what you're trying to accomplish with this master keying process is part of the goal. And with Kwikset, because we don't have the small 15,000 pin, you can pretty much do just about whatever you want. So they can hand you 2 sets of keys. Here you go. I want these to work here and not to work here. And you can pretty much just do that. Old school reference is shoebox keying. And sometimes that works. It's not ideal, but for little tiny systems like that, it's great. And then we're going to go dive into the 2-step system today. We're going to show how far that can go and what the limitations are. How many change keys do we have in the typical 2-step Schlage system, Jerry?
2-step 6-pin Schlage system 4096, 5-pin system 1024.
Okay, there you go. So that shows you the difference. And then when we get into that advanced 70 system, we can really see how that can really massively expand your system. Now, let's relate that to the real world, right? For simple math's sake, if I wanted to take over a strip mall, or we're designing a master key system for a building that has, 100 tenants, right? We've got 100 tenants in there. Your typical 2-step system is going to work. The math is going to be easy. You can punch the keys out on a punch machine. You don't have to go to that next level and redo that math and redo your cuts to make it part of the 70 system. Now, that's going to be the easiest way and the path of least resistance, and it's going to give you enough change keys that you'll be able to maintain those 100+ doors, no problem. Now, let's say we go take over a bank or somewhere that has many, many buildings, right? And we've got what, 500, 600 different places that we have to be able to master key the system to, and we have to be able to have change keys so we can maintain it for a few years to where we can rekey that system, keep it on the system, and maintain it throughout the entire process. Now, that's where we're going to need a larger amount of change keys, and that's where that 70 system is going to come into place, and that's what Jerry's really going to talk to us about a little bit later, and that's why this is advanced master keying. We're also going to touch on keyway keying as well. So if you have Schlage and Sargent are the two most common ones. If you have the different keyways, you've got E and K and H and the SC20. There's actual cylinders that the SC20 cylinder has a very wide open cylinder. So it will accept all of those different keys. So that would be the lowest form of security. It would take and allow all of those C through K keyways to fit in there. But you can restrict where those keys can go based on the cylinder and the keyway. So if we have an E cylinder or a K cylinder in certain locations, then we can restrict what those are going to go to simply by the keyway. You can actually have the same cuts as the master key, but if that key doesn't fit into that cylinder due to the keyway, then it's not going to work, right? So there's a lot of different ways that you can actually key control that system. And it's not just all based on the bitting, it's actually based on the keyway itself. So we're going to touch on that as well. So with that, I'm going to go ahead and I'm going to get this pulled up here. So we have advanced master keying presented by myself, Wayne Winton, and Jerry Dionisio, and we're going to, oh, I'm sorry, what is it? Dionisio. I'm sorry. Yes, sir.
That's okay.
All right. And we're going to jump right into this one here, and we're going to do a short recap of the basics. I'm going to let you go ahead and jump in on this.
Basically, it's asking what is parity. Parity is anything that is even stepped. In other words, if you take a odd number and add an even number to it, you end up with a, Wayne?
Huh?
If you take an odd number and you add an even number to it, you end up with a odd number.
Right.
Correct?
Yes.
Okay. So, and if you add an even number with an even number, you always end up with an even number.
Right.
So therefore, that's why we use parity. The master in this system that I use, you only use master pins in the advanced section. In the two-step section, we only use master pins of 2, 4, 6, and 8, period. Mm-hmm. And that'll give us, in a 6-pin system, like I said, 4,096 different possible changes. Of course, you have to count for max. Why use parity? It prevents ghost keying. It prevents people by a ghost key. I mean, one key that does not, one key that kind of says, oh, wait a second, I can pass into this lock. We don't want that. So we go ahead and we make it very restrictive, very so that you cannot, with a 15 thousandths difference, you can go ahead and possibly get that key to work. With a 30 thousandths difference, it's very difficult to get that master key or that change key to work in a different cylinder that it was not designed for. Then the next question is, what is progression? Progression is how you go ahead and progress how the system rotates. In a 6-step system or in a 6-pin system, you have your progression is A, B, C, D, E, and F. You can go ahead and in that you can arrange the progression in any order you want. In other words, you could have it B, C, D, A, whatever. I have to write this stuff down to memorize it because I just can't pull it off the top of my head. But it can, any place that position A is in, it rotates every change. Any place that position B is in, it rotates every 4 changes. Any place for C rotates every 16 changes. And D rotates every, I got that wrong. A rotates every change, B rotates every 4 changes, C rotates every 16 changes, D rotates every 64 changes.
Right.
Right?
Mm-hmm.
Okay. E rotates every 256, and F rotates every 1024.
Right. Yep. So, and then just so people do understand, there is part 1 for this master keying program as well, and we go over max violations in detail, in a lot of detail, and I actually show on the cutaway cylinders what it looks like and what everything really looks like and why those max violations are so important. And we show why those 15 thousandths master pins are not really good for systems. You want to avoid those, because what happens is that 15 thousandths over time, number one, with cheaper brand cylinders, like non-OEM cylinders, non-factory cylinders, Schlage or whoever it is, they're going to be a whole lot more sloppy. Even the residential ones are going to be a lot more sloppy. The tolerances just simply aren't there to be able to handle that 15 thousandths pin. And yes, you might get it to work a couple times, but when you watch that video and you watch the cutaway cylinders, you could see how over time it wouldn't take very long as that pin starts to wear down, or as the cylinder starts to wear down, or as the key starts to wear down. It would not take long for that 15 thousandths to then get trapped in between the plug and the cylinder itself, or the plug and the Bible. And then you're going to have all kinds of problems. And anybody who's set up one of those systems and it's been in place or been in use for a couple of years, you know exactly what I'm talking about, because you're going back and you're doing quite a bit of warranty work on that, and your system is basically destroyed. Not the way you want to go about it. And whether you're taking over somebody else's system and you see that happening, you're going to have to eliminate those from the equation. You might even have to just start over. And that's a really good place to start. So just to kind of get everybody refreshed as to what master keying actually is, we're just going to do this little mini master key system. This is one I quite literally just did this week. And it was that exact system or that is situation where the customer said, I want these 3 locks to work on this key. And then I want this lock that's going to be the owner's closet to work on this key. And I want the owner's closet key to work on those 3 locks, but I do not want those 3 locks keys work. I don't want those to work on the owner's closet. So it sounds a little complex, but it's very, very, very simple. And we'll just go ahead and show how that works out real quick, and we'll go from there.
All right, so we're going to be doing some master keying here, and this is just some Kwikset stuff. This is just a kind of a unique situation. Kwikset doesn't have quite as many rules just because of the way the cuts and everything are set up. So this is the key that we have, and this is the key that they want to have work with it. They want 3 locks where this key works, and then this key needs to be the master, and then this key does not work in this lock, but this key works in this lock. And this is how we've got it decoded here. So you can easily see that we've got all the numbers. So we've got our 11344 is our lower key, or our change key, if you will. And then our master key is going to be 13314. Okay, so I'm going to do this just a little bit more up close and personal, and I'm going to show you exactly how we can do this. So I'm going to put the key in. This is the key for this lock, and I'm going to go ahead and peel this back. This is one where you do not have to take it all apart. If you try and take that clip off, you might bend it. So we're just going to go ahead and do it right through here. Now, right now, this key works. Everything meets the shear line, right? So the first thing I'm going to do is I'm going to insert this key, and I'm going to see that we've got one where we need to add a master pin here. You can see it's lower, okay? Let's see if we can blow that up just a little bit. And then this one's too high. So I'm going to dump him out, okay? And then we're going to look at our boxes here. We write the lowest number down here first, and this is the bottom pin. So we take 1 and 1, 1 and 1, 3 and 3, 1 and 1, 4 and 4. Okay, and then on the ones that are the same, if it's 1 and 1, there's no top pin. If it's 1 and 3, the 1 goes down on the bottom. The difference to make 1 to 3 is 2. So we need a number 1 bottom pin and a number 2 top pin. Here we have 3 and 3, so 3 with no top pin. That's why it's working here. And then here we've got a 1, and then a 3 makes the difference of 4. Okay, so hopefully that's making sense to everybody. Kwikset number 1 is going to be a 171. We can grab, should be right here. Okay, bottom pin has the point on it. Okay, good. So now he's all even and happy, right? Even and happy, right? Okay. So then we're going to need to put our number 2 top pin in here. That's Kwikset is going to be an 045. So 045. We're going to put our 045 right there. Tuck him into place. And again, nice and even. Everybody's happy and moving correctly. Then I'm going to take that key out. That key has been completed. Now we have all the pins necessary for a 13314 to work. And then now we put this in, and you'll see we've got this one standing up a little too high, but that's okay. It's still going to meet the shear line, right? It's still meeting the shear line. So that's how that works. Okay, that bottom pin is the bottom shear line, but we're a little low here. So this is where we need that number 3. We're going to go to Kwikset, number 3, top pin 069. Okay, 069, top pin. Right here. That's going to slide right into there, hopefully. And there it is. Okay. So now that's working. And I'm going to actually pull the key out since we can't rotate it with all of those pins in there. You saw that one was trying to stay trapped. Now it's pushed in, and what do you know? Lo and behold, our 1134 key works. I'm going to put this little flap back, and our other key, our 11344, also works. Beautiful. Okay, so there's some shoebox master keying, if you will, or just kind of making what is already on site work, because this is for a house that they want one owner's closet locked off of. That's it. We're not doing anything ultra complex here. But that's Kwikset, and this is how you do the math, and that's how you make the whole system work. Then this key does not work in here, okay? But there it is. That one works. No problem, okay? And these do not. So, thing of beauty. There you have it.
Okay, so that's going to be our basic, at the most basic possible master keying. Like here, I need these to work and I need this to work. And it's on a Kwikset system, and you can literally make what's there work, or you can choose to cut new keys and build a system however you want to build it. I chose to just use what was there because there wasn't any violations, and they would have gotten extra keys and whatnot anyway. And that's the way that they requested it to be done. So now getting back to our presentation here, let me get that back shared here. And we're going to do this. And we're back. All right, Jerry, go ahead. Do we need the next slide?
Basically, it's asked what's the highest key in a master key system. Of course, we all know that's the TMK, and the lowest key is the change key. Yes, sir. Next slide, please. So we have the TMK, which is the top master key. A change key is the lowest key in anything that we do. Bitting is basically how we put the cylinders together, the pins we put in there to make the pin stack, which would be considered the bottom pin, the master pin, and then the top pin, of course, is in the Bible. We have shear lines. That's how the cylinder turns, or the plug turns inside the cylinder, and of course, maximum adjacent cut specifications. Those are all the terms that we use: TMK, change, bitting, pin stack, shear line, and max. Basically all approved and everything. This is the standard way locksmiths talk. Some people will say, well, I don't understand. Well, TMK, think about it, top master key. So it's, it's logical once you go ahead and understand the terminology. Change key, well, you change it. That's what you go ahead and actually give the tenant or the owner of the unit that allows them only to get into that, only to get into their unit. I use apartments as an example because I've done a lot of apartment complexes, and a lot of commercial buildings where their tenant only gets into their suite per se.
Right. Yeah. And the change key is the one that's also designed to be changed. So as you progress through the system, okay, this is the tenant. Now this person is going, that's the one you're going to be cycling through. That's the person who's going to be changing the lease. If it's a strip mall, then it's the individual business that's going to be there. Or sometimes they take over 2 or 3 businesses. One starts growing and you can add those to it. Or you just change it next time it needs to be rekeyed and you keep following your system, and then you can keep them on the master key system. I wanted to just go ahead and relay a little bit more information as to why this is so important as well, and maintaining your systems and making sure that they actually stay on the master key system. Because we know in our job several times I have gotten phone calls from property managers or apartment complex owners that the individual tenant has rekeyed that lock, not knowing or not notifying the property management company. Now, a lot of times this is in the lease, but a lot of times people don't read the lease either. And all of a sudden we have a pipe break, or we have, something happen in that room. And we need to get into that room, and then they go and they get their master key and they go to put it in the lock and it doesn't turn. Okay, well, what happened? They probably called somebody else, and then somebody came out there, was unaware that that was on a master key system, and just rekeyed it. And now there might be some master pins in the top, there might be none. Who knows? We don't know who did it and what their ethics are when doing so. Again, this is really, really important. Why it's so important to make sure you follow your pins out or follow your plug out with a master pin follower, or dump those top chambers in there. That should be a standard operating procedure for a professional locksmith. And I know we get ahead of ourselves and we get short on time. And, if we don't see any master pins in the bottom, then we figure and assume that there's just none in the top. But that's never the way to really go about it. I would always recommend running that master pin follower through there, or dumping those top pins out, so you can verify that there's no additional pins in there. And that is the only way you can guarantee, hey, I put these pins in there, I've rekeyed this lock to this key, and this is the only key that will work in this lock. That's the only way you can verify that. So just some ethical things to keep in mind as you're going throughout your day. And then the other important part is fire department, right? They mandate that a master key be put in a Knox box in both business, commercial, and residential locations in the event of a fire or a problem. One other thing that I've actually had happen is gyms, right? Gyms that have people go work after hours. You get somebody that gets in there at 2:00 in the morning and they hurt themselves and injure themselves working out. They got a bar stuck on them, or they've injured themselves, pulled a muscle or something. And they might be calling for help, but then people can't get in. Right. So that's where having that master key available and having that Knox box is going to prevent the door from being broke down by the fire department, because they're going to get in one way or the other. One way is the nice way with the key and nothing gets damaged, and then the key goes back into the Knox box. And the other way is with axes and hammers and sledgehammers and pry tools. And now you're buying a new door and a frame, and that's probably going to cost thousands and thousands of dollars. And not to mention the time being unsecure, because as soon as they break all that stuff down, that business is no longer secure, or that home or that residence. So that is why it is so important to make sure we maintain that. The amount of damage that can get done from a pipe leaking when it's first discovered to when they can find a locksmith or find somebody to come out and unlock that, and hours of water dripping into something could be the difference between tens and thousands of dollars of damage in that building. So a wide array of reasons why this is so important to keep keys on their master key system, maintain those master key systems, and to keep them up to date and make sure that everything is accurate. That is our job as professionals, is to help the other people that engage and work with these systems, like the property managers and fire department, to make sure that they have a good operating system that works when it needs to work. All right, let's bring this back up. And we want to go to the next slide, or you want to?
Yes, sir. And we're done.
Good. There we go. All
right. You want to do it, Wayne?
No, go right ahead.
Why advanced master keying matters. Large facilities require layered access control. Hospitals, schools, offices all need strict. They need strict hierarchy. By hierarchy, I mean what levels work in what keyway, or what levels work in what cylinders. Poor planning creates future dead ends. Max violations reduce usable changes, and proper progression preserves expansion capabilities. Basically, we just go ahead and make sure we have enough changes in the system to facilitate however many changes they anticipate, because your property manager, again, I'm going back to my apartment complexes stuff, they know how often they go ahead and turn doors. They know how often they turn tenants. So when they turn a tenant, the good property managers would go ahead and say, hey, I need to have this rekeyed. Others would just, anyway. We all know what others would do. Proper progression preserves expansion capabilities. So if one key was 23234, you can change it to a different one. I would not use 23236 because, well, even though it's able to work, you want to go ahead and get it off of what that was, as long as it is in the same area that would work the master key and everything, so that everybody's good. I change all 5 pins to a different cut that would be in the master key system that you've designed or you're using.
All right. Common advanced master keying mistakes, ignoring max violations. We showed that in the first one. And so what that means is when you have a very deep cut next to a very shallow cut, what'll happen is that V shape, that V from the valley from one, will start to interfere with that next adjacent cut. So maximum adjacent cut simply means that this cut is going to start violating this cut. And again, you might be able to get away with it for making it work while you're pinning it up. You know what I mean? Like you might be able to get a 2 and a 9 right next to each other, or a 2 and a 0 right next to each other. But you'll see that it's just barely riding on a little tip. And then again, if you have another deep cut right next to it, so we got deep cut, shallow cut, deep cut, right? Then you're going to have both of those deep cuts affecting that shallow cut, and it's just going to be riding on a little peak. And when you have the tip of the pin riding on the peak of a key, it is a recipe for disaster. It is only going to have to go in and out of there a couple times before it wears down and those peaks start to not meet, and you start to have problems and complications with your master key system. And that's what we're really trying to drive home. And there's some very good examples of that in the first class, which we did put in the chat section. There is a way you can watch it over there. Just follow that link in the chat section. I will also put this in the description when we record this as a official recorded video, and you'll be able to check out all of these systems. Jerry and I are actually probably going to end up doing about 4 different master keying programs, one with basic. This is advanced. We will most likely be doing a high security one and an SFIC one, AT pinning as well, because it all applies to this, and each one has its own set of special rules along the way. So that's how we thought that we might break that up. So everything you wanted to know about master keying is all going to be involved in each one of these different seminars here. Then we've got not documenting the system of hierarchy properly. If you don't keep good records, you can plan on failing, like fail to plan to fail. Writing it down like you saw my little piece of cardboard in there, right? That is not, that's not a way to maintain a system like that, right? But that's one individual home. So we're going to be able to move that around. If they want that rekeyed, we're going to have to rekey everything, and we'll know exactly what's going on in that, because we're talking about 2 keys. Right? We're not talking about maintaining multiple systems. So making sure you update your records and keep your records up to date. Doesn't matter how you do it. If you want to do pen and paper, that's fine. You just have to make sure that you keep your records accurate. If you use a system, you use some kind of a software program, whatever program you choose to use, then make sure that you add it to that system and you update it so that you know when you go back to that location, this change key has now been changed to this change key for this unit number. and you actually have the unit numbers all there. And make sure that you keep that system secure. That's one other thing that we should go ahead and take a minute and talk about. Anytime you have a system on your computer or on pen and paper, I would make sure that that's put in a safe somewhere. If they've asked you to actually keep keys for that system in the case of an emergency and they want to be able to reference you, it's just all about being upfront and honest with the customer. And there's a lot of different ways people want to do this. Some people do not want to assume the liability. Some people will say, no, I will not maintain your system. I'm going to give your system to you. And every time I come by, I will update it as we go through it. And then I'm going to give it back to you. I don't want it. Right. The other one is, I want it. I will keep it. I'm going to keep your master key system in a safe if it's written down in a secure area, not your vehicle, not just locked in your car, because you could smash a window and get that pretty easily. And then somebody could quite literally have the keys to the city. You don't want to have that. You want to have it locked in a secure location, in a safe, somewhere secure where you can reference that material and then put it back and update it after you're done. Or if it's in a secure file, a secure cloud file, a secure computer, make sure your computer has a password. Like, we've got to think about all the different layers. If somebody steals your computer or your phone, do you have it in a secure location to where nobody's going to be able to access that through reasonable means, right? We're not talking about DEFCON hacking here, because we all know that, security has its limitations, but you want to make sure that you protect your customers and your clients' information, and you maintain those records as good as possible. Then we've got poor expansion planning. So if you want to talk a little bit more about that, Jerry, talk about, if you didn't plan enough changes, you might run into a problem here.
Exactly, Wayne. If you don't plan for enough changes, if you say, okay, fine, well, the page 1, 2, 3, and 4 don't work right for me. 1 and 2 is be fine. Make sure you have enough changes to go ahead and keep the customer happy. Basically, that's our entire goal, is to keep the customer happy and keep the person that is asking you to do this, keep them happy so they go ahead and continue to use you. If you say, oh, well, gee, I sort of ran out of room, we got to go ahead now and rekey everything, they're going to look at you like, why? Didn't you plan for this? So basically, plan ahead. You want to make sure that there are enough changes. I've seen more times than not, people go ahead and put constants in. Constants, to me, decrease the number of viable changes, because by a constant, you keep using the same pin over and over and over in all the changes, and it depletes the number of viable changes that you have. Now, in a residential part, that's fine. If you're going to have 2 or 3 or 4 rekeys, that's fine. And you go ahead and have 2 or 3 constants in there, no problem. But when you're talking buildings where there's the strip malls, the apartment complexes, the commercial side of it, you want to go ahead and make sure that there are enough changes. Avoid, if at all cost, avoid constants where that one pin doesn't go ahead and do anything. Basically, in a 6-pin system, if you have one constant, your 6-pin system went from, ready for this, 4,096 possible changes down to 1,024 changes. That's a major difference. You're basically rekeying or repinning a 5-step system then. You've gone ahead and literally eaten up one of your changes.
Right. Yeah. And that's again, so always understanding what is your end user's need. That's a really great point that Jerry brought up there. All right, we've got an apartment complex. What keyway is it? Okay, we've got a Schlage keyway. Is it a 5-pin? Did you order 5-pin or did you order 6-pin cylinders for that? Okay, well, you've got all Schlage residential hardware, so you've got a 5-pin system. Hey, this is how many changes we can do with that, right? And you can lay it out. This is how much we can do with that. Or we can order, in most of those situations, it's probably going to be a deadbolt. You could probably add a 6-pin cylinder to that if you wanted to, and you can change that. But you need to know that they need that, right? And then, okay, well,
Exactly.
why would we do that? Well, we go from the 5-pin system that has this many changes to a 6-pin system that has this many changes, and all we need to replace is the cylinder for the deadbolt. You take one screw out, you put your new 6-pin cylinder in, you put the screw back in, and everything should go back together and work just fine. But you need to work with your property management company. You need to work with the maintenance division and find out, what exactly do we need here, and what do you want the end result to be? Like you said, the last thing you want to do is say, okay, well, we've maintained your system for 5 years and you guys are out of changes. We can't change this system anymore. There's no more change keys available. We now have to rekey the entire system. That, I can guarantee you, the face on your property manager and your customer is going to go very grimacing, because they know how expensive that's going to be.
Yeah.
Now we got, 300 units that we need to rekey at whatever you charge to rekey those locks. And you're going to have a ton of time, ton of materials, ton of labor, ton of everything. And not to mention, how much are you inconveniencing your clients? I know when we do master key systems, it is always a logistical nightmare trying to make sure that the tenants get the keys, that, are they going to be there? How do we get the keys to them? We don't want to leave keys under, floor mats and stuff like that. That's not going to be a real helpful, secure way to do things. So you need to work with that property management. What are we doing with key distribution? How do we get the key to the customer? Have you sent emails out? Is somebody going to come back and expect their key to work, and then it doesn't, and they get on a flight, they're trying to come back at 3 a.m. and they need to get to their room? I've gotten that phone call. Hey, what happened? I'm locked out. And it's the system that I just did 3 weeks ago, and now they came back from vacation and they're locked out. Okay, so how do we get that person that proper key? How do you get the staff that key, right? And what do we need to do? What are we trying to accomplish? Again, we need to have the change keys for the individual tenants. We need to have a maintenance key to be able to get into certain rooms for certain maintenance people. There might be specific cleaning people. If it's a commercial application, not so much in residential. And who else needs to get in there, right? Just think about, if they're handing a plumber a master key, and then they're handing an electrician a master key, and they're handing a locksmith a master key, and they're handing somebody else a master key because they want to hand that key out so they can get into all those units. Now you got a bunch of master keys out there, right? That's not going to be the best scenario. So who needs to have access to what, when, where, and why? And that's where you need to start, and then work backwards in your system. Okay, here's these keys are going to work this block. These keys are going to work this block. These keys are going to work this block. And then this is going to be the TMK that's going to work everything. You need to really, really spend some time, some quality time with your customer, and help them understand what the end result is going to be, so that you can maintain something not for 2 or 3 years, but for 10, 20, or 30 years, and not have to go back in there and start over again. So all really, really good points that you've brought up there, Jerry. All right, let's get into page 1 here.
Basically, this is page 1 of 64, a 6-pin master key system. TMK cut is 201375. I got to make sure I read that right. 2710. Yeah. Your progression A, B, C, D, E, F. You can see in the. If you don't mind highlighting, I don't know if my mouse would work, Wayne.
I can't really do highlighting. What do you need here?
I need you to basically, you see A progresses every change. So you got your master key is a 2, so you have your next change would be a 4, then 6, then 8, then 0. Right. Basically, you're doing every other step.
Right.
So that's how you get. That's how we call it a 2-step master key system.
Right. This is the 2-step master key system here, and this is what most people are going to be familiar with. This is what you're taught at just about any convention or just about any basic master keying system is going to teach you this 2-step progression, which uses 2 cuts and goes down each time you change that 2 cuts each and every time. And I do have a video here on that as well. So we've got our two-step master key system here. Sorry, Jerry, I can't really highlight anything on there because it's
That's okay.
image.
I don't know if you guys can see my mouse or not.
No, you can't. No,
Okay.
I'm the only one that has the ability to do that, but it doesn't show the mouse actually on there.
Okay.
But we'll show you exactly what this means, and so we can see this chart here. And what we're going to do is I'm going to remove that, and then we're going to go ahead and do another little screen share on this side. I do apologize. I'm not sure why the video is buffering just a little bit. We must be using quite a bit of bandwidth doing a live broadcast and then playing some of these videos as well. So we're doing the best we can with what we have here. Master key and cutaway cylinder, two-step system here. All righty, we're going to be doing some master keying today, and we're going to be using this system here. Number one thing is have a nice clean pinning mat. Each one of these pins over here, these are the bottom pins, and these are going to be the top pins that we're going to be adding to our system today. We're going to be doing a two-step progression, and these are going to be all the bottom pins, and those are going to be all the top pins. Now, let's say we're taking over a master key system. This one already has, okay, so we can check this out. I got these really cool cutaways custom made just for this. Okay, so you can see really nice down deep inside there as to everything that's going on, every little click, every little tiny thing that's happening. And we'll go ahead and show that, and then we'll do our master pin follower here. So I'm going to just go ahead and turn that up, and you can see the shear line that we're hitting there. Okay, take that down, take the cap screw off. Cap screw, detent pin, and detent spring. Then we're going to insert the key back in, rotate 90 degrees, and we're going to use a master pin follower because we're going to get some of our master pins out with this, and we're going to get the rest out with the actual master pin follower. Okay, so there we have it. Now check this out. Okay, master pin follower is going to be a great little tool to have. And what do you know? When we click this thing around, and they will drop right out, and then when you rotate it over, they come right out into the end over here. Now obviously not everything would be a cutaway like this, so they wouldn't be able to fly out, but that's where they'll mostly come out. They'll come out over here, and then you simply dump them out in your hand and get rid of them. And then to rotate everything back up, we use that master pin follower to just come right around, and then you can see it rides right up on that edge. Okay, nice round edge, and we have just dumped all of the master pins out of this cylinder. Now we're going to empty this out. Those keys are going to go away, and we're going to start pinning this cylinder up here. Okay, and we're going to start off by using bottom pin number 2, just like we're going to do on the chart here. So we're going to shove our number 2 bottom pin in there. He's going to be nice and happy. And then we're going to do our number 2 top pin. Okay, happy, happy. We've got a 0, so our first cut on our TMK is, our cuts for TMK are going to be 201375. Okay, and then the next one here, we're going to do a 0 bottom pin in our second cut. We're going to do a number 2 top pin on him. Shake him around till he's laying flat and happy. Then we're going to be doing a number 1 bottom pin with the number 2 top pin. He's going to be laying down there nice and happy. Then we're going to do a number 3 bottom pin, number 2 top pin, number 7 bottom pin, number 2 top pin, and a number 5 bottom and a number 2 top. Okay, so that is exactly what it's going to look like. Okay, beautiful. Gotta love the HD cameras and stuff that's going on today. Okay, that's what it's going to look like inside there. Now, when we're master keying, we can't really put the keys in the cylinder and put it in unless you have a very simple system and design it that way. So you need to load all of the pins in first, and then we're going to find out A, if our math is correct, and B, if we actually have the correct pins. Because if I pulled these out of my pin kit and there's a wrong pin in the wrong section in the pin kit, I will find that out right about now. Okay, so there we have it, and then everything's going to come together like that. Wow, that's beautiful. It's really, really cool looking. Okay, so I just want to point out a couple things here. Number one, again, these cutaway cylinders are very, very special. I had these actually custom ordered from a guy that does these professionally on Instagram. He has a bunch of different really cool cutaways, and you can see that he's actually figured the math out to maximize this window to still be able to keep those pins in place to be able to see what's actually going on, but with a maximum view portal here on that. And that's one of those things that you're not going to see this anywhere else. I've never seen a cutaway cylinder that big. It's crazy, and it's really cool. And that's what I really like doing, is I really like adding an awesome visual so that you can see exactly what's going on in there. And then I took that 1 second and I actually slowed that down in slow-mo video in the editing software, so you can actually see everything click together. You're not going to see anything else like this anywhere else until after this, that people might be copying me at some point in time. But for now, this is really groundbreaking stuff. Jerry's got a groundbreaking system with the 70 system, and this is groundbreaking as far as visual aspects and the 4K videos that we can see, and slowing it down, maximum windows, just really being able to understand from every aspect and every point of view what is happening inside the cylinder, so that you can understand it and build a visual as to what's going on in there when we're building these master key systems. I just wanted to take 1 second to talk about that. All right. Amazing. So, okay. There we go. Okay. But beautiful. Okay. So we can see that TMK is all just the bottom pins. Okay. Then I'm going to rebuild this so it's not quite so sticky. I'm going to put our spring back in, detent, cap screw, tighten, back off one. Let's try that again. Oh yeah, nice and smooth now. Okay, that's our TMK going in there, nice and smooth and easy. And then we will get our Blockmaster. Okay, Blockmaster. And beautiful, smooth. We've got 1, 2, 3, 4 of those top pins engaging with the Blockmaster. Thing of beauty. Got our Grandmaster, or I'm sorry, our Group Master.
That should be changed.
That's the one. What are we calling that one?
That one should be a column called a column master. That should work 16 changes in the entire column of that sheet that we've shown.
Okay,
so we'll go ahead and show it further in the video.
All right. So when we refer to that, it's going to be referred to as the column master.
Correct.
What do you know? Thing of beauty. That's our GM. And then finally, we have our change key. All right. Thing of beauty. Now all of the master pins are in the plug with our change key. Okay. Absolute thing of beauty. That's amazing. Okay. We'll pop that out. And that is our change key. So there you have it. We have now successfully rekeyed this cylinder using the two-step pinning process and rekeyed it to this nice little cutaway cylinder that shows everything that's going on inside there as we move along throughout each step. So very good. All right. So again, like Jerry has figured out a mathematical way to expand on the typical Schlage system with his 70 system. He's utilizing math to the maximum mechanical aspect possible. So is the person that designed those cutaway cylinders. They actually figured out the mathematical equation and the thousands that could be taken out of there to where just the sides barely hold those pins in place. And we're getting the benefits of that through this course, getting the visual aspects and getting an entirely new concept of math to be able to maximize these systems to points that have never even really been considered before for certain applications. So really cool to be a part of it. I'm glad that we can help put this on together. And I hope that people out there are really seeing the amount of work, time, and dedication that both Jerry and myself have put into this course for you today. Let's see here. Justin says, yeah, he'll wait. Had to answer. Okay, not a big deal. So we'll get to that other system here in just a minute. We'll bring up our PowerPoint presentation back up on here, and we will continue with that. Are there any other questions based on the two-step system that we just went over, seeing how it works on paper, and then seeing how it works on in the system as well, seeing how it works with the actual pinning, like taking this is the exact system. This is the exact same key that we have right here, that this TMK and this block is exactly what we just used. So you can see how it works on paper, how the keys are cut, how the pins are actually put into the cylinder, what pins go into what key as you're working that system, and how everything blends and works together. If there's any questions, go ahead and put them in the chat section now, and we will answer them on the two-step system only. Jerry, is there anything else that we need to know about this so far until we move on to the next slide?
And the next slide, it's going to break everything down the way you've already shown it, Wayne. And this basically here is our basic warning. MAX stands for maximum adjacent cut specifications. Each lock manufacturer sets its max limits. They know how much meat on the key it will be left, and they know that Well, can I go ahead and do an 8? No, it's not going to work because it goes ahead and takes away too much of the tip on the key that you were talking about, Wayne.
Mhm.
It sets a limit. That's the maximum cut depth difference allowed between the two adjacent pins or the cuts of the key. If two adjacent cuts on a key are too far apart, in other words, a 0 and an 8 in a Schlage system, the pin, like you said, is just going to ride right on the tip. And after about 3 or 4, maybe 10 times, that key will not work properly. And of course, they're not going to come to us to go ahead. I'm a locksmith, been doing it for 40 some odd years. They're not going to come to us to have the key cut. They're going to go to the easiest convenient place, and they're going to give them the key to cut, and their machines are not calibrated like ours are. So they bring it home, they try it in the lock, it doesn't work. What do? They get upset.
Mhm.
So you've got to make sure everything is copacetic with the manufacturer. You have to know the max violations on different ones. Kwikset is a 4, Schlage is a 7, Sargent is an 8, Yale is 5. You have to know all that. You have to remember all that. Throughout the class, keys highlighted in red have max violations, and you'll see this in our next set of slides. The max violations on the charts are going to start showing up, and anytime we say could means you could have that many changes. It doesn't mean you will have that many changes. So that's why could is always in green on everything we do in this entire first part of the master key system. Exactly. 191 will never work.
Right. So yeah, I think it's important. We're just gonna bring this up in this one too here, and just show this little video real quick so that we're talking about max. We need to really drive that home.
Okay, so now let's explore what happens with max violations here. So we're going to get a blank, and I'm going to show you what it looks like, and then we'll pin it up, and then I will show you based off of this key that is currently cut to 191817, and we can see what that looks like and how it affects the maximum adjacent cut to that next cut. You can see that there's just a little tippy top right there for that pin to ride on, which is going to cause a major problem and major flaws in our master key system, which is not going to be real happy about that. So if we violate the max, let's see here. If we violate the max, and let's say we do a 1. So we've got a 1. Okay. A 9. A 1. And an 8. And a 1. And a 7. Okay. So now this is pinned to this key code right here. Okay, 191817. Now, if there was no such thing as max, this would be matched perfectly and it would be even. See that this one here is lower, okay, and it's lower. And that is just barely riding on a teeny tiny little tip right there. So any fluctuation, any wear of the key, as soon as this key gets any wear whatsoever, it is going to start to not function. And then you can see how the 9 cut took out half of that 1 cut. That's what a 1 cut should look like, not that. Okay, so when we look at it that way, you can tell that it's not going to take a whole lot for that to not start working. Okay, so that is why we do not violate maximum adjacent cut.
Okay, so hopefully that provides everybody a really good visual demonstration as to point on point and how much that's what you're supposed to look like. Like that's a pin happy in its home. He's got a nice wide berth to sit in there, and it's a good situation. This is not a good situation. That is not having a good time right there. That is bad news, and that is you having lots of warranty work and lots of recalls and very, very upset customers because that system's not going to work. It's not going to work at all, especially, and then you add master pins on top of it. You're asking for a world of pain. That whole system needs to be dumped, thrown in the garbage, and start over again. If you're trying to take anything like that over, just dump and start over again. And you got to let your customer know. But again, I want to put that really good visual to it, so we don't just say, hey, don't violate max. Max is very important. We say it, but then now when you see it, now you can really understand, wow, that key is going to come in and out 2 or 3 times. And it's brass on brass. You've got brass pins on a brass key. They're going to wear together. That means every time you insert that key and every time you pull that key out, it is taking a little bit of material off of that key. Those springs are pushing down hard on those pins, and it is rubbing, and you're creating friction. I don't care what kind of lubrication you put in there. It's not going to matter. It is always going to have some kind of friction, and those tips are going to start wearing down on both the pins and the keys themselves. And that's what we want to prevent. We want to have a long-term 10, 20, 30-year system that we can maintain, and that customer is going to not have to change master keys as long as there's not a discrepancy in the in that master key getting into the wrong hands. You should be able to maintain that system for quite a while, and that's what we're trying to teach you here today. All right, ready for next slide?
Sure.
Okay.
Basically, it's asking a 2-step. What's the hierarchy of a master key system? In a 6-step system, you can have 7 different hierarchies. Hierarchies are basically your change key, your block master, your column master, your page master, your 4-page master, your 16-page master. That all goes through everything. So a change key, it's the lowest key in the system. When you master pin a cylinder, you always take the highest key and you do the math against the lowest key. So in other words, you take the math for your TMK, which we're using here in this example, and then we will go ahead and figure out the cuts or the pin stacks that we'll use in the change key. All keys not highlighted in this example could be valid changes. Notice again, the green could. You cannot say will, because there's no way the only way it would work is in a system that does not have any max. The only one that I know about is the A2 system. Best A2 system has no max. There are all viable changes.
Yeah, they literally built that system for master keying, for large master keying systems. They took the math and they designed the pins and the cuts and the adjacent cuts based off of master keying, so there would be no violations. They designed it specifically to be master keyed because you have to have a shear line for the control lug and the control key, and then you have to have a bunch of different changes. And it was literally designed for large department stores, big box stores, chains, banks, different places where they're going to be sending these cores out a central location can send these cores out. We understand why, who Best is and what they did. They wanted to be direct to end user. You will keep track of your system and we'll send you the cores out. And they've changed a little bit since then. And they're, working with Locksmiths more now. But that system was specifically designed for master keying. So therefore they designed it to not have any violations like that.
Exactly. Okay, can we go to the next slide, please?
Mm-hmm.
Okay, so you saw the change key on the last slide. All those could be change keys. Again, could be. The Blockmaster, this key highlighted in yellow, could operate the 4 cylinders directly above those changes. Or directly above the Blockmaster. Each page has 16 blocks on a 2-step system. Next slide, please. You see here all the things, all the blocks highlighted in yellow are Blockmasters, or can be considered Blockmasters. You also notice that there are red highlights. Those are your max violations. The max violations, again, we don't use because, well, you can't have a 0 and an 8 together because it will not work.
Exactly.
So how do we accommodate have these 4 changes? What do these 4 changes have in common? Basically, if you look closely, you'll see that positions B, C, D, E, and F are all the same cut. 2, 3, 5, 9, 7. Next, please. So we're wondering, what do we do? Like it says, it all has the same cuts, 2, 3, 5, 9, 7. They've been filled in to the yellow section. Next slide, please. Now the question is, what key do we cut for all 4 cylinders to work with just one key? That is where we go ahead, and if we hit the next slide, you'll see that we use the first cut in the TMK. The TMK then goes ahead and becomes a 2 in that Blockmaster. So you use 2, 2, 3, 5, 9, 7. Therefore, all 4 changes will operate their own change key, the Blockmaster key and the TMK. That key cut is 2, 2, 3, 5, 9, 7. Again, this is an art demonstration. What you have on your master key systems will be totally different unless you're using the same math, which we did, well, this is going out to the world. So I caution.
Let's jump in and put a disclaimer, because I know that there are key courses, master keying courses taught at many different suppliers, and they have a very similar format where there is certain cuts that were used for demonstration in the program. Do not use these cuts and do not design your system based on these cuts, because there's probably somebody else out there watching this video and they're going to set up the same system too. Oh, that's easy. I'm just going to use what we saw in the video. Please, disclaimer, do not do that. Do not use the cuts that you see here. This is for demonstration only. We wanted to give you a visual. We wanted to show you that it works. We wanted to show you that it works with the cutaway cylinder. We wanted to show you what it looks like cutting the keys and doing the entire process. But this is for demonstration purposes only. Please do not use this system and start designing your master key system for your clients around this. You need to just start over from scratch and pick a different TMK. Otherwise, everybody in some city is going to have 2 or 3 buildings with the TMK of 201375, right? And we don't want to have that. We want to avoid doing that.
Please don't do that.
Disclaimer, put out there, do not do that, okay? Are you ready for your next one?
Yes, sir.
Okay.
So now we come to the column master. Again, this key could operate the 16 cylinders in that exact column. Next slide, please. So you see 16 changes here. Well, we know we can't use the Blockmaster to go ahead and do everything because you have 4 block masters there. You have 4 different sections that are left blank. Next slide, please. The progression of C, D, E, and F use the same cuts in the column master. In this instance, the actual cuts are 3, 5, 9, 7, and they're all in the same cuts in this in all 16 changes. So you have to excuse me too. Sometimes I get dyslexic even with my own math here. So we have the same question again. What do we do? Next slide, please. We use the same logic as we did for the block master. The column master uses the progression positions A and B from the top master key, or the TMK. The keys now that operate all operational cylinders in the column are the TMK key, the column master key, and all of the change keys. The block masters only work in those 4 other blocks. They do not work the other 12 changes there. Questions?
Let me just take 1 second and see if we have any questions over here in the chat section. Let's see. Wait, had to pause. Demonstration with the cutaway would be great visual. Okay, yeah, we did that. Violating max can cause difficult key insertion, premature wear, pins hanging up, reduced reliability, and increased key breakage. Yes, you are very good. Oh, and that's another really good point too. If you have the luxury of designing your own master key system and starting over and scrapping what they have, a very good suggestion would be to not have a very deep cut for the first or second cuts. You want to have a higher cut. You notice that we've started off with a 2 and a 0, right? Those are going to be good cuts that you can have there because it will tend to make that key weaker, especially when you get into like Sargent systems that I can't count. I've got a customer who has a very deep cut as their first cut on every single one of their keys for a large Sargent system. And they keep fighting me on redoing everything because they obviously don't want that expense. But I also go there once or twice a month for broken keys.
Yes.
You know, so how many service calls is it going to take before they just bite the bullet and go ahead and do that? So when you're designing your system, if you have the luxury of designing it from the get-go and you get to put your cuts that you'd like to start off in there, start off with higher cuts for those first cuts, chamber 1 and chamber 2, the first cut closest to the bow of the key moving forward. Or if you're A2 pinning, that they do that backwards. You count the first cut is the one towards the tip, and then you work your way backwards. So not trying to confuse people out there, but just want to make sure that we understand. Deep cuts towards the end of the key is going to be a better solution for that.
Also, Wayne, you can go ahead, and there are people out there, not all of us are angels. They go ahead and they see a key and they say, oh, let me try filing this and see if I can make the master key. Now, I have to take my hat off to Tyler Thomas, who went ahead and pointed that out to me. And I thought, that's a great idea. Because if you go ahead and you can file a high cut, especially if you have a 0 cut, they're never going to get the master key.
Right. Yeah, that's a great point. And again, when putting this course together, this wasn't a fly-by-night, hey, let's just, teach the same stuff that's been taught over and over and over again. I wanted the people who are taking their time to be here, we are utilizing your most valuable asset and resource, your time. Okay. And we didn't charge for this. Your time is valuable, and we understand that. And you're here with us on a Saturday if you're live, or if you're watching this recording whenever it's convenient for you, which is why we're trying to bring this to you, right? There's the number one request is more online on-demand training. And this is me bringing that to you in the best way possible and not making it boring. We talked with industry experts. Tyler Thomas is one of the best at setting up huge master key systems with ultra high security systems. I mean, he literally wrote his own software and he wrote his own program to do things like that. And we conversed with him and we consulted him and we consulted other industry experts too. What are the main problems with master keying right now? Well, that you just brought up is one of them. If I have a little bit of knowledge, and actually with YouTube University being out there, there's a lot of knowledge that can actually be had if you know how to navigate to the correct videos. We're still at about a 10-to-1. You know, you might have to watch 9 videos to get one good one with some good information in it. But there is a lot of information out there. There's Reddit forums. There's all kinds of places out there where people can get information. And if you're a bad actor and you have ill intent, you could actually utilize that information to try and capture even a change key, and then, like you said, file that down, use a hand file, and keep trying that in there until you get what may be a master key. Well, if you design the system, and that's what's great about the system that we're using here, is when we design this system, it's already baked into it that the TMK is going to have an O cut or some high cut into it to where you can't file that down. You can't add material back to the key to be able to do that. And even to the point of 3D printing, I've seen a lot of discussion going on there about 3D printing and taking a picture of a key and 3D printing a key. And it's had mixed results. The plastic really isn't strong enough yet. And if you're trying to do that with master key systems, especially if you get into something more high security or high tolerance like Sargent, even trying to 3D print a Schlage key, the problem is in the milling. It just isn't quite there yet. I know it's probably going to get there at some point, but it's not there yet. But we've taken the time to consider those new options that weren't available 10 years ago. We didn't have 3D printers that could print off a key based on setting it next to a quarter and having somebody design a system that will do that. AI is doing a ludicrous amount of figuring these things out and creating these programs and making it easier for the common criminal or bad actor or thief to be able to utilize these tools to bypass security. And we need to think about that. And we've actually considered that, talked to industry experts, and actually baked that into this system so that it maintains security as much as possible while understanding that simply master keying in general is the destruction of the security of that lock because it adds multiple shear lines to it. So lots of complexity, but this is not your average master keying course that you're going to get just about anywhere. This is real high grade stuff with a lot of stuff that hasn't even been considered in the industry yet. And Tyler, big shout out to Tyler. He's a huge help and was a huge asset in building this course as well. Go ahead, Jerry.
All right.
You want the next slide?
Yeah. So you basically see here that the blue highlighted 203597 will go ahead and operate all the change keys in this column. Next slide, please. I feel like I should do a little ding.
Ding. Yeah, you can. That's all right. We're getting through it here.
Okay. Basically, here's your column master. Block masters are in yellow, so you see where the block masters are. They were filled in on this example. Your max violation is in red, and the column master is in green. That way it distinguishes everything. Next. Two-step master key system hierarchy from the lowest key to the TMK. What's next on the agenda? Well, that would be the page master. Now we've had the change key, we've had the block master, the column master, and now the page master. Page master, this key could operate 64 changes on a single page. That's great. What would a page master be used for? In a building that has a cleaning crew, you could give a page master to the first page of the system to the janitor. He can go ahead then and get in every room that he needs to, if every cylinder is keyed from the first page or the page that the page master is cut from. Next slide, please. So, next slide, please. Now comes the page master. In a 6-pin two-step system, there could be 64 unique changes. Now we know in the example we're using, we already have 4 that are max violations. The logic is the same one we used for the block master, column master, just a bigger scope. Block masters use position A from the TMK, where it could operate 4 cylinders. Column master uses positions A and B from the TMK. It could operate the 16 cylinders. A page master uses A, B, and C from the TMK, plus D, E, and F from that page, and could operate 64 changes. Let's look at how the workbook page now, with all this information, is filled in. Next slide, please. Yellow is the block master. Green is the column master. Notice the 4 column masters has a max violation. Now, the 4th column has a max violation in the column master. You see a 209. 09 won't work, guys. Sorry. We've talked about max violations before, and you can see right there that a 09 will not work. Wayne has shown a 1 and a 9. A 0 and a 9 definitely won't work. The blue is the cuts that we used from the master key or the TMK, so that these keys would work. So you see the page master of 201, again, A, B, and C from the TMK, 201, and the page that we're working on, page 1, the last 3 are 5, 9, 7. Now the 5, 9, and 7 will have more. We'll talk about that as we progress further along in the hierarchy. Next slide, please. Thank you. Two-step master key system hierarchy. We're now going to go ahead and talk about the 4-page. You see, everything is just recapped. What we're talking about is highlighted or is bold, and this key could operate 256 changes. That is one large number of cylinders. So it says cylinders, should be changes, but because there could be 6 changes that use the same cut. Next slide, please. Trying to show 4 pages of a workbook on a single slide, single PowerPoint slide, would be too cluttered. I have tried, and it just looked like there's no place to put in comments or anything. So we're going to show a different way now. We're going to use a, shall we say, a tree method of what or how it's going to look. Our TMK is still the 201, 375, and we use the same logic to determine the 4-page master key. You see, we always, as we grow up in steps on everything, we go ahead and use the next logical progression. Now in the 4-step, we will use the D position. And I also want to draw your attention to the max violations in pages 3 and 4. Both have max violations for the master pin or for the page master. So those page masters could not be used. That's why you have to go ahead. You must go ahead, print your entire system out, make sure you know where your max violations are, make sure that you have as few max violations as possible when you build your system. Okay. 4-page master key uses position D from the TMK. So you see how we've gone ahead and moved the 5, 7, 9, and 1 to the 3 of the master key or the TMK. So the 4-page master that could operate 256 changes is 201, 3, 9, 7.
Perfect.
Questions?
Yep, I'm gonna just pause here and let's see if anybody has any questions going for this thing. Just because I don't want to lose anybody. If we lose you here, boy, you're gonna struggle a lot. You're gonna struggle a lot moving forward. So anybody, if there's any questions, put them in that chat section, put them in that comment section, and let us know if there's any questions up to date so far. Hopefully we're following along. We're following the progressions. You're able to see based on the individual blocks and the numbers, and you can see how each one of those is changing, and it's systematic. It's not random at all. It's mathematically systematic throughout the system, and we're still working on that two-step conventional progression system, just like you're supposed to be working on, just like most common systems here. Once we jump up to that 70 system, things are going to get very complex very quick. So we want to make sure we have everybody on board right now. I think we're looking good.
Would you mind if I gave out my email address?
Yeah.
If anybody
Ren can put it in the chat section, or you can give it out. You can say it too.
Okay. If anybody has any questions, I look at it this way. Any question that is not asked is the dumb question. I don't care if you ask the question 3 or 4 times. Keep asking it until it makes sense to you. My email address, if you want to talk to me, is jerry@masterkeymanager.com.
Yep. And we'll put that in the chat section too, so it's in there. Yep. And people can use that. Thank you.
Thank you.
All righty. Any other questions, comments, concerns? And again, that's jerry@masterkeymanager.com. Okay. You ready for your next slide?
Yes, sir.
All righty.
So now we're going to look at the 16-page master. This key could operate 1,024 changes. In the workbook. 1,024 changes is 16 pages. 64 times 16 is 1,024. And let's see how let's see this on the next slide, please. So you see that we have all the math through the 4-page masters keys, where they are the 2019, 201317, 201337, and 201357. By using the same method we've used for every other submaster, from the block master, column master, page master, 4-page master, and now we're going to go to the 16-page master. Now we'll see how it's done. Next slide, please.
Yep, and I'll jump to that next slide. I just want to jump in here 1 second and kind of help explain this to people as well. So what we're doing is designing the system so that when you hand out, let's say you hand out the key to that janitor or to that person who needs to get to the maintenance areas, when we change the change key, we don't have to give him a new key. It's already designed for him to keep his same key. The property manager keeps that same key. That's why we have the block master and the page masters on there, because those are specifically designed to be that higher key in the system, so you can go through changes without having to replace those keys and give those keys to those new people. That's what we're doing here. When we break it down and boil it down to the raw essence, that's why we're doing it this way. Okay, there's a logic and there's reasoning behind it. Otherwise, every time you'd rekey it, you'd have to hand out new keys to those upper management people as well. And you want to keep it simple. You want to make sure that when we change a key, when we have a change key, that tenant no longer has access. The new tenant will. That old key is not going to work in that system, and it's not going to work on any other lock in that system throughout the entire life of the change keys, by the way. And we don't have to hand out new keys for the property management companies, the staff, the cleaning crew, and those entities as well. That is why the math is so, so important on this. And that is why it's so important to maintain the system, to keep track of the system, and to make sure that you're maintaining throughout the life of that master key system. It's an ecosystem. It's alive. It's constantly changing. And you need to make sure it's your responsibility to keep it alive and keep it maintained as we move throughout the system.
So now we come to the seventh step in the hierarchy, which is the TMK. Again, it says this key could operate all cylinders in a 6-pin system. All right, sir. So in a 64 page master key system, we have up to 7 levels of hierarchy. Number 1 level is the top master key, called the TMK. 16-page master key is called the 16-page master. A 4-page master key is called the 4-page master. The page master key is obviously called the page master. Column master, the one that works the 16 changes in that one column, is called the column master. Then we have the block master that works only 4 changes in that block. And finally, we come to the lowest key, the change key. That's what you give the tenant. So we have 4,096 possible change keys, 1,024 possible block masters, 256 possible column masters, 64 possible page masters, 16 possible 4-page masters, 4 possible 16-page masters, and 1 TMK. Questions?
All right. We'll leave that open for just a minute. I like how you termed the master key system is alive. Yes, it is. Treat it as such. You got to feed it. You got to maintain it. You got to take care of it. And it will take care of you. And it will make you a lot of money. And this is the difference between professional locksmithing and the trunk slammers down the street, right? Anybody can go out there and make 2 different keys work in one lock or 3 different keys work in one lock. But it's an entire ecosystem to be able to make sure that you can maintain those systems. You're not constantly handing out new keys. They consistently work over the years and over the decades, and it's not just a one-time, one-and-done deal. And the other thing I wanted to address real quick, too, is there's a lot of concern with access control. And access control is taking over a lot of aspects of things. And that we are moving more towards an electronic aspect. But there are still a ludicrous amount of multifamily living units that are, they're constructed on bare bones budgets. And they're utilizing keyed hardware. They're not access control yet. They're not putting $400 or $500 electronic locks on there that integrate into a system. Some are, but some aren't. And again, even if you have the best electronic system in the world, the best parts, the best access control, the best software, the best hardware, the best everything, as soon as there's a natural disaster, as soon as the power goes out, as soon as there's a hurricane, fire, earthquake, natural disaster, and the power goes out or the internet goes out, your system is dumb. You go right back to dumb. We go right back to the dark ages of the good old key. And guess what? That system still needs to work. There's still going to be a fire department that's looking for a master key in a Knox box. That system still has to be maintained, and it has to be set up from the get-go, because behind every piece of electronic hardware, there should be a good quality mechanical key system that works hand in hand with it. So if you're not doing the electronics, you can still get quite a bit of work based off of doing the master key systems and doing the keying for everything else behind the scenes. And that's where you can choose what kind of system you want. Now, as we'll talk about this a little bit more, but as we put together that high security master keying system, that's really the way you kind of want to start pushing people. I would always highly encourage using that high security system, simply because you've seen that adding all of those different master pins, when we pulled that cylinder out and you can see the cutaways, look at all of the different shear lines in there. How difficult do you think that lock would be to pick? Probably not that difficult if you're a skilled lock picker. Probably not that difficult if you're not a skilled lock picker, especially with all the tools, the leashy tools, and all the different things that are out there now. You have a much higher chance of hitting all those different shear lines in any. It doesn't matter what order you hit them in, as long as you hit those shear lines, you're going to bypass that lock. Now, if we're doing that on a high security system, they don't have leashy tools for that. Those are much harder to pick. You have to have a secondary shear line that's included with that. And those are things that we'll cover in those other systems, but I just want to address it and touch on it for now. If I have a client, let's say the city or a police department, we recently just did this. They wanted some access control. And then we talked about their key system as well. And their key system was out of date. Their master key system was a mess. Everything was just totally and completely butchered. It was a terrible system to get into. And they said, hey, the people who have been maintaining this have not been doing a very good job, and we want to hire you. And I said, okay, that's great. We're going to have to, if you're going to hire me, I'm not going to do Band-Aids on gunshot wounds. Okay. You have a gunshot wound. You've got a blasted shotgun here. Okay. We need to start over, and we're going to put you on high security Primus. So we're going to put you on high security Primus. We're going to build you an awesome master key system. It's going to be maintainable. Your access control is going to be your day-to-day routine. If and when the power goes out, which happens all the time here, you'll be able to use that master key system, to override that. And you'll be able to have an extra layer of security, knowing that there aren't leashy tool picks for that. It's got its own custom sidebar. You can't go to Minute Key or the key kiosk or whatever kiosk you go to. It's not a request of please do not duplicate this key. It is actually an order of you don't have the blank and you can't legally purchase it in order to try and copy this key because I have rights for the system that we bought into. I've spent a ludicrous amount of money buying my own Primus system that is mine for my customers, and they get that peace of mind and that added level of security. And you as the professional have to be able to display that and explain that to your customer, because all they know is a key is a key, right? They don't understand all of these complexities to it. And so it's your job to educate them. You have the education. You're coming here. You've taken classes. You've invested your time. You're the professional. You're the knowledge source in the situation. So you need to educate your customer as to what's happening there. All right. You ready to get into the tips and tricks? Do we have any other questions? I don't see. Thanks for the training. Oh, we're not done yet.
Oh, no.
Don't leave yet. We've got some really cool stuff.
Really neat stuff.
Yeah, we've got really cool stuff on here. You have a slide of the lock only and unlock?
That's the fourth section.
Okay.
First section will be the multiplex systems.
Okay.
And then we go into a Schlage pins into a Kwikset cylinder,
Okay.
which will boggle everyone's mind.
Mm-hmm.
And then we go into the System 70. So that's the third part down in here.
Okay. All righty. Sounds good. All right. Multiplex systems and keyways. Let's jump right into that. Oh, let's see here. Let's pull that up. There it is.
Multiplex keys and keyways. We look at how different sectional keys. A sectional key, we'll show this here to you in a bit. Let you key in entire complexes, even campuses with thousands of doors under one TMK, under one master key system, one TMK. Yeah, it's possible. It's doable. It's been done. I've done it. While preserving the integrity of each individual building's keying, including all the way down to the tenant or the user. Imagine having 2,000 doors in a college campus. Each key has their own cuts. Yeah, it can be done.
Yeah,
it is done.
Yes, and so let's dive into that just a little bit more. So we've seen that, and we'll have some more slides and whatnot on here. But if you've looked in your let's say your ILCO book or your Master Keying book or key blank book, when you're trying to order key blanks, you'll see that there are, in certain aspects, I believe Schlage and Sargent and Yale has it too, I believe, but there are the different hierarchies where different keyways will work in different cylinders, and different cylinders will accept different keyways. Okay. And they're all designed to integrate together. And here's where something like people that own hardware stores would get in trouble for this a lot, is they would order the highest keyway on the system, and they're like, well, that'll fit all the other ones, so we'll just order that one. Right? Makes a lot of sense. I don't need to stock as many keys now. Or if you're a mobile locksmith, I don't need to stock as many keys now. The problem with that is you are contaminating the multiplex. Okay. And there is we've been talking about master keying and key control based on the cuts that are mechanically possible and master pinning in the individual cylinder itself. What we're talking about with multiplex master keying and key control is this key could have the same cuts as the TMK, but it literally will not go into the lower grade cylinders, the lower security cylinders. It won't fit in the hole. The key profile will literally not fit into the keyway. And therefore, if the key doesn't fit into the cylinder, it can't access the pins, and the pins can't sit in the cuts, and you can't turn the lock. So this is exactly what it's for, is because maybe, 4,000 changes sounds like a lot. That sounds like a lot. But when you're talking about a campus like CU Boulder, or, whichever campus you're talking about, a large university, a hospital, a skyrise building, this is stuff that, Tyler really works on. It's, high-rise buildings, banks, just people that have a huge, massive system. We need, 5,000 changes. We need 5,000 individual keys and cylinders, and we need to be able to maintain that for the next 10 years and be able to have changes that do so. Now we're talking about an entirely different level of master keying, and that's why this is in the advanced class. So I hope we're not losing anybody. We are controlling where the key goes and what the key does and what that key controls by the profile of the key and the profile of the cylinder and the cuts. Go ahead, Jerry.
All right. Using sectional or multiplex keyways on a two-step master key system, you could end up with, ready for this, 36,864 theoretical changes, and where one TMK key will work all possible changes. Here's how it's done. Next slide, Wayne. This is where the magic happens.
We're bending. It's like the Matrix. We're like bending the rules of reality here with what is mechanically possible.
Yeah, 36,000 changes. I mean, come on.
There you go. You're set up.
A multiplex keyway system uses different sectional keyways, and you'll see how that's laid out here on the next slide. The family keyways within the family of cylinders. They make cylinders and keys that can be, let's say you want a cylinder to work only with the one key. So in other words, if you have a C key, you want to make sure you have a C cylinder. You have a CE key, it has to be into a CE cylinder. I'm using Schlage. And again, I'm stepped ahead. We have to make sure everything works under one master, one overall master key system. This allows separate groups of keys to operate independently while still permitting high-level master keys to access multiple sections or the entire complex. Let's use an apartment complex as an example. Me and my apartment complexes. There are 3 separate buildings in each complex. Each are in the complex. Each contains 400 units. That's 400 changes per building. The property owner wants one TMK to operate the entire complex. You're going to look at that and you're going to say, oh, how do I do this? Okay, wait a second. So we want to still maintain a separation between each building, and at the same time, you must account for frequent monthly rekeys due to constant tenant turnover. Okay, Wayne. Here's the apartment complex that AI created. Sorry. Had to use something, and I didn't know where I could find something like this, so I didn't want to drive around Denver all day trying to find something. Okay.
Yep. You got the next one?
Yes, sir. Here is how a multiplex system is laid out for Schlage. You'll notice that we're going to multiplex systems, sectional keyways make this manageable. Right now, each tenant door in all 3 buildings uses a standard 6-pin Schlage C keyway. So basically with a, hopefully it's a 6-pin, you have 400 changes per building. So that's 1,000. We have in 1024. You won't even have enough to go ahead and have with just the C keyway. There won't be enough room in a 5-pin system. So you need to make sure it's a 6-pin system, and then you need to go ahead and start using your sectionals or your multiplex keys. So we want to make sure that we have one master key or one TMK that operates across all 3 buildings, while each tenant key still operates only their door.
Correct. And so if you've seen these, if you've seen this in your key books out there, when you're going to order keys and you're wondering why are all these lines drawn on here? What does all this mean? What are these key groups and what are these keyways? What does all this mean? That is what we're trying to break down, and that is what we're trying to explain to you now, to where you can have that lower level that's only going to operate exterior buildings or one certain building, and then we jump up to the next level to where, okay, well, now this building is going to be on this keyway, and then this building is on this keyway, and this building is on this keyway, but you can still have that top level key, that highest level keyway that's going to fit into all of those other cylinders. The keyway profile is going to allow it to fit into those systems. So let's say we take that number that we used before, and we've got a change key, like our TMK is what we started with, our 201375, right? That's going to be our TMK cut on the highest level, the 20 or SC20 or whatever it is, the keyway that works and fits all of those different profiles. And then your change key. So we could have literally a change key in each one of those 3 buildings that is 623592. That bidding will be in each one of those buildings, but building A's key is not going to fit into building B's keyway or building C's, and vice versa. Building C is not going to fit into building A or building B. And that is how we can really, it's called a force multiplier, right? We're multiplying our options, not based off of the bidding solely. We're maximizing it based off of the keyway profile, so that keyway, the SC7s go to this key, this building, SC8s go to this building, SC9s go to this building, right? And that's how you can really build and expand that system. And that's when these things started to come into play, when we had systems that outgrew the amount of change keys that were possible. Then the manufacturer said, okay, well, how can we get with our engineers and come up with a solution for this? And this is advanced stuff that very rarely ever gets talked about. As a matter of fact, I have not even really heard or seen this discussed and broke down to this degree in any of the classes that we've ever taken, which is exactly why, if I haven't heard it or seen it, I want to bring it here, and I want to put a magnifying glass on it, and I want to explain how it works, and not only how it works in complex terms. Jerry has 4 decades of information and knowledge about how to make these systems work and why they work on paper. How do we sell that to the customer? How do we make the customer understand, and how do we make you understand how these multiplex systems work and why they work and why they're established and why these different keyways exist? That is the purpose of what we're doing here today. Ready for your next one?
Yes, sir.
Okay.
Okay, so it says, therefore, we will use the following cylinders and keys for the rekey. Building A will stay with the 1145A, or the 6-pin cylinder, an SC4 keyway. Building B will use a CE keyway. The CE keyway will not go ahead and work in either the C keyway or the E keyway. And finally, we have building C will have the 1145A, 1145E 6-pin SC9 keyway. For this master key, we'd use the sectional master key, an A1145H or an SC15 that will operate all three keyways. If you notice the lines from the SC4, the CE, and the SC9 all arrow down to the A1145H or the SC15. That's telling us that the 1145H key will operate those three cylinders, or those three families of cylinders. So if you have the 1145C, which is in building A, don't need to do anything. You can buy either plugs or in the entire cylinder. I have not been able to find. I called my wholesale house yesterday, and of course my wholesaler couldn't give me the answers right away. He'd have to look into it. So it's all possible. It is possible to just change the plugs, as long as you're working within the family. A family of Schlage 6-pin. In other words, you can swap out the 1145A plug to an A1145E plug into the same. You can swap the plugs out into the same cylinder.
Right. And then here's an important thing to know. This is where your responsibility is. You have to understand, if you, or even your technician, maybe your technician is not as well versed and hasn't taken this course and doesn't understand this system. Hopefully you send this course to your technician so they do understand it. But let's say you go to cut a key, you get a call, and your technician gets a call to go cut a key for building B. And they pull out an 1145H or the A1145, the SC15. You have just now given them a key that will operate that lock in all three buildings, right? Okay, so think about that for a second. You have just contaminated the system, and you have just opened yourself to liability, right? I'm not an attorney. I'm not giving you out legal advice, but I can tell you that there's probably a good likelihood that if you hand the wrong person the wrong key, and you are supposed to be the professional, and something bad or tragic happens, or a crime is committed, right? There will probably be an attorney that's looking for somebody to blame. And who's going to be to blame? The person who is supposed to be maintaining and have the knowledge to maintain that system professionally. You should know that you hand that key to that person, and it's going to open two doors that it's not supposed to open. And I mean, holy smokes, what if you accidentally cut them something higher up? What if you cut them a block master or a page master on that key blank? Now they're going to have access to hundreds of different rooms, and you are going to have a really tough time trying to defend yourself in court as to why you did that and how you're not responsible for that happening, right? That's not a good thing to have. You do not want to find yourself in that position. So I'm actually going to even go back on this one here, and we can kind of see how that tree branches out, right? So we've got these three right here, the SC1, SC4, SC8, SC9. That all is going to branch down to that SC15 here. Then these are going to branch down. The middle ones are going to branch down to that 1145J. And then these are going to branch down to that 1145K. Now, what happens if we really go nuts and we gave somebody an SC20, right? I know that Lishi makes an SC20 pick for all of the different keyways. And that's a great, powerful tool, because if you come into any of these, if you're a maintenance person or a locksmith and you need to pick a lock to come into this situation, which if you had your master key system maintained properly, you wouldn't need to pick the lock, now would you? But it will fit in all those different keyways. So really, now you hand them an SC20 and you hand somebody a blockmaster, you might as well have just handed them a master key to the entire facility, because they're going to go almost anywhere that they put that key in. It's going to open almost everything. So knowing and understanding these key charts and these trees and these multiplex systems is part of your professional duty, in my opinion. And this, again, is not just Schlage. This Sargent also has a similar system. And I believe Yale has a system as well with these multiplexes. So knowing what key blank you're copying on is going to be extremely important, or not even copying, but reduplicating or recutting, right? Any of that can happen. So those are the dangers, and those are the red flags, and those are the bad things that can happen. And you can't just claim, I didn't know, right? That's not a very good excuse. I didn't know is not a good excuse. Now you know. Now you're here. Now you've taken this. Now you understand. Now you know. So not keeping SC20 key blanks and just saying, oh, well, that's gonna work on, you know, all of the systems that we need to maintain, because we have those systems here too. There's tons of condos, different condo buildings have that, and there have been people that, okay, well, here, we'll just hand you an SC20 blank instead of an SC9. Not good. Not good. Somebody says A1145J and 1145H can CrossFit right for SC9. Okay. Good information here to have. And yes, so understand your multiplex systems, learn them intimately, and learn what clients you have these systems in place, and how you can maintain that, and how you can add your professional aspect to it so that you can maintain these properly.
Okay, here's the workbook. Again, we're using the same one we've used in the Advanced Master Key class earlier. You'll notice that the TMK is now labeled the Master Key. I didn't change the slide, sorry. But it's A, and the 16-page master is grouped as AA, 4-page master, AAA, and the page master, of course, page 1. This is for the building A. It says right at the top there, 1 Master Key Boulevard, Master Key Colorado, and it's a Sargent system. Keyway is 1145A or A 1145C, it should be. No, yes, 1145A should be 1145C. It was a typo on my part. And no, the phone number is not correct. So we have the A1 highlighted in green using that cut of 443597 would work then just in the building building A with an 1145A key. You could go ahead and create 3 separate workbooks. You have for the 1145 for your SC4 key, your CE key, and your SC9 key. You want to create 3 different workbooks to go ahead and maintain the changes for your H key or your SC15 key.
Okay. We've got a question here that they want us to go over that multiplex one more time, and we'll just use this one right here. So we've got SC, let's say SC4, SC9, and SC10. So we would use building A with SC4. We would use building B for SC9, and we would use building C for SC10, right? We could use those different keyways.
Yes.
To be able to maintain each one of those buildings. And now SC4 is not going to fit into SC9. SC9 is not going to fit into SC10. SC10 is not going to fit into SC9. And SC10 is not going to fit into SC4. So the key will literally not go in to those cylinders. But That way we can use the exact same master key block. So when we're talking about our system here, right, and we're going back to our blocks, we can use this system with the different keyways. So we can use the same pinning 3 times. Does that make sense? We can use the same cuts. Let's say unit 101 in building A, the change key is 623597, cut on an SC4 key blank. We will then say unit 101 and building B, the cuts again will be 623597, cut on a SC9 key blank. And then for building C, we will cut 623597 on an SC10 key blank. SC10 will not fit into SC9, so 101 in building C cannot get into building A or B, and A or B cannot get into B or C, and B cannot get into A or C. However, we can have one master key that operates all of these systems in an SC20 down here at the bottom, and it will go into SC4, SC9, SC10. It will go into all of those different keyway profiles. And if that one, the TMK, is back to what we were talking about with our demonstration, 201375, it will then open every single lock on all 3 buildings. Does that make sense now? Hopefully, perfect. All right. Yes, thank you. We have a good feedback. So we're explaining this. I know it's complex. I know it's very complex, but that's exactly why I wanted to bring it to everybody's attention and to have this course and put it out there, is because it is complex. And until we really lay it out like this, until we explain it like this, and we show it with a visual, we show it with a PowerPoint, we show it with a picture, we show it with the building, and we show it with the key tree on there as well, it takes all of that to put it together so it makes sense. At least that's what it took for me. Because when you're just looking at pictures and trying to understand this, it's practically impossible, right? It's very, very, very high-end locksmithing, very complex systems that we're trying to understand, because you have so many things that this is when keys were based off of mechanical limitations. We are based on how many changes based off of the cuts and the pinning due to math. And then they expanded it out when they said, we have hospitals, we have college campuses, we have 2,000 units in each building. We need more changes. And then every year, right? Every year, building A, B, and C get an entire new set of students in there, right? And on a college campus. So the last year's keys, they handed them out to all their buddies. There's 27 different keys running around for Unit 101, and now they need to maintain security for the new group of students coming in. You're going to have to make sure that you can make those changes happen and keep those changes. That's why the SC20 is so sought after. Yes, it is, but that's also why you shouldn't be handing it to anybody except the top tier level person. Anybody lower on that system asking for a SC20 key blank or a high-end TMK like that is not, they do not need that. You need to understand who gets what keys and why, and that needs to be established on your paper, right? Or in your system. You need to know this is the only person authorized. There's one person authorized on campus to issue TMKs or higher level keys. Okay. So hopefully that's making sense for everybody out there. And hopefully we're clearing this stuff up. And this is exactly why we're bringing this to everybody. Do you need the next slide?
Building has 2,835 valid changes. After 400 tenants, keys are assigned. That'll leave 2,435 fresh changes remaining for future keys per building. Each key retires the old bidding. Don't use the same bidding over again. You're only going to get yourself into trouble. Mm-hmm. Giving the buildings years of secure key rotation. Now, I used the H master. Wayne went ahead and got all the way down to the L master. But with what we're using, the 3 groups that I had originally, the 1145A, the 1145CE, and the 1145E, with the A in front of the 6-pin ones, we have this many changes there. So if you do the math real fast, 2835 times 3, 7,000 changes or so. So that's what is available per each building of 28,000 or 2,835 changes. Any questions?
Let me check the questions here.
Have I lost anybody?
If there's questions, go ahead and put them over there in the chat section. I think everybody's doing good so far. I think we're breaking it down and once again putting the visuals to the text and then actually explaining how that works in the real world. These systems live among us. There are universities, there are hospitals, there are campuses with in military too, government agencies. Yep. We have thousands and thousands of people that we need to maintain key control on, and it's 4,000 changes sounds like a lot. Well, it is until you have 5,000 people on campus, right?
Exactly.
That makes a huge difference. So then we'll go into some other multiplex keyway options.
Corbin Russell has many many multiplex systems. There are too many for me to list in that little small area. General has one keyway. It's a very small. There are only 4 different keys in a general key. That's, again, for the general cylinders and what have you. Sargent has 4 keyways that will work. It's a C, H, L, and R. Schlage, again, 1 keyway, again, but we have 9 different breakdowns per the cylinder. Yale has a large amount, but Yale only has a max of 5 for most locks. So we've got to be very careful on how we pin up a Yale. Yale will kind of, shall we say, not work too well on there.
Okay.
Here is a breakdown of a small section of the bigger section. The 1145 or the Sargent L sectional. The 1007 LA is actually known. I'm sorry. The 1011 LA is actually known as the SC. I'm sorry. I've gotten Schlage on my mind. What am I trying to say, Wayne?
S20, S22?
Yes, S22. Thank you. I went through the book that I had, and it had pages wrong, so I had to go ahead and doctor a few things. But you can see how the hierarchy in here just goes bananas, where everything crosses over and goes here and goes there. I mean, you look at this, and if you're not really understanding it, you're going to go, huh? So you have to understand this before you can recommend it. If people don't understand, email me. I'll go ahead and try to explain it further. Put your phone number in. If you need me to call you, I'll call you. I mean, I'm retired. Yeah, sure. I've got a few things under my belt that I've got to do, but I'm more than happy to go ahead and accommodate any locksmith out there that has questions. Because I have a couple customers that call me almost daily going, how does this work? So, you got to explain to them. You want them to be good quality locksmiths out there. You don't want the fly-by-nights. You don't want the people out there that are, like you said, trunk slammers. You want good professional locksmiths.
Okay, we got a comment here. Reminder, the higher level in a multiplex system, the thinner the key is in order to pass through the keyway. Be aware of breakage over time. So yes, those higher level keys, what it's doing is they're reducing material so that it fits in that keyway profile, right?
Exactly right. That's
more. That's right. Yeah, that's how it works. So you do get a thinner key. Going back to if you're designing your system, making sure that those really deep cuts are more towards the end and that you have those higher cuts towards the bow of the key. those are going to be all really good aspects that you're going to want to make sure you keep in mind when you're designing these systems. And again, how many times are we really going to see a system like this or take a system over like this? I mean, I just don't know how many are still out there. But the reason these were created was this was before access control. So when
Right.
government, when the army has a base or the military, like we've got family that lived on military bases, and you go to Camp Pendleton, right? There's thousands and thousands of Marines that live on that location, and they need everything from the general store to the individual homes to lockers to training facilities to all of these different things need to have a key system that integrates together. So this is the mechanical version of expanding access control as far as we can possibly do it. They got engineers together, Sargent, Schlage, Yale, all of them. They all got people together and they said, how can we make this system work? Well, we can expand off of it by elaborating the keyways and making certain keys fit into certain locks and not into others. And these locks get these keyway and this lock gets this keyway. And then this keyway fits into both of those, or 3 or 4 or 5 or 6 or 10, or however big that system needs to expand. And that way now the amount of changes can grow astronomically, because every single time we add a new keyway to it, every time we add a new cylinder and a new keyway, you then push that to another power. You expand it all over again. Back to explaining, I can do the same pinning for building A, building B, building C. And then if you expand that further through the systems, if you have more keyways, then building D, E, F, G, all the way down. As long as you have another keyway that's compatible with the system, you can keep expanding that system out and still keep one TMK that works in all of it. That is the whole point behind it. Now, obviously, these systems were created, 20, 30, 40, 50 years ago, because we didn't have the access control systems that we have now. So having somebody come to you and want to build this system nowadays, probably going to be a whole lot less often of an occurrence. I've never even had anybody approach me about, like, we're building a new building, let's start this. It's always taking something over that has already been done that way, because they had a lot of different apartments or a lot of different buildings that needed to be maintained under that same key. So hopefully that, again, puts it into perspective. When am I going to use this? When is it going to apply into real life? When are we going to be able to use this for our business? How can we turn this into something that we can service? You can take these systems over now that we understand that. Now that if you feel comfortable with it, and if you have the software to be able to actually decode that system, maintain it, and then continue to maintain it throughout the years, then you're golden, right? That's all good stuff to have, versus turning that job away and letting somebody else do it. And that's the other thing too, is you also want to be a locksmith company that's going to be around for the next 10 or 20 years to maintain those systems. Or you need to take those records when you sell your business and sell them to another local person in town and communicate that with the owner or with the people who you're working with. And I've always been told, or I've always been taught, hey, we're going out of business, we're selling, I'm closing, whatever. Do you want to buy your master key system? Do you want that information? Or do you want me to sell that to another locksmith who's capable and competent enough for you to maintain that, right? Those are some different ethical ways about going about that, but communication is key. You need to communicate with the end user, and you need to communicate with the person who's going to be taking that over, because they're going to be tied together and married, right? If they don't like that new person, that's going to cause some problems if they don't provide the same level of service that you did as well. We want to put some business aspect in the way to think about this for your business as well, whether you're accepting new clients, taking over multiplex systems, taking over master key systems, or whether you're phasing out and selling them and, downsizing, if you will. All right. Let's see if we have any other questions here. But good point. Yeah. Bill said that key gets thinner. That's a good point. Good point. All right. Now we're really going to break people's brain.
Yeah. How about using a Schlage depths in a Kwikset cylinder? Why? Well, it's a practical hybrid method of creating more usable changes in a Kwikset system. You may have, case in point, the apartment complex again. They're saying, I don't want to go ahead and spend all that money. And they have Kwikset on their doors. I've seen it, I've worked on it, and I've done this system. It's amazing how it works.
Yeah. So the way we'd find ourselves in this position is you got a contractor, they're the lowest bidder, right? We're just slamming some stuff up. They ordered whatever was cheap, whatever had the cheapest dollar sign. They paid $10 a deadbolt for these things. And we're doing this on a bare bones budget. They didn't plan, right? Back to planning. The architect, the engineer, the contractor, the general contractor, the owner, the end user, they didn't plan on how they were going to maintain this system when they got it. They didn't know to think about this. So they ordered the bargain basement stuff, the cheapest hardware possible, like those Defiants that I was rekeying, right? And now they're saying, oh, we've got to maintain this. If there's a pipe leaking in apartment 201A, how are we going to get a maintenance person in there so that they can solve that problem while maintaining security for everybody else? And it just clicked in their head. We need a system so that we can have a master key that opens everything for our maintenance. And then we have a maintenance key. And, if we need to evict people or we need to get in there for whatever reason, this is what happens now. Now they've already got 6 different locations with 8 different buildings, and they're all on this same system. Now you're saying you're doing the math and you run it through whatever system you have, or you're just doing the math. Well, we can key them, but we've got about 200 changes. How long do you think it's going to take to go through 200 changes at 6 buildings at 10 different locations? Probably not very long, right? So how can we expand upon that? How can we utilize what we have? So then you're going to have the conversation with your customer. Your hardware is not compatible with this. You need to buy all new hardware. They just bought that hardware. How's that conversation going to go? You're going to be out the door, and they're going to call somebody who knows more, who tells them what they want to hear, right? And you can use this to your advantage. So when you're bidding against somebody else, and that person, your competitor locksmith, says, this is not mathematically possible, right? You're only going to have 200 changes. You're going to be out of changes, and we're going to have to redo the whole system in 6 months to a year, right? That's not very viable either. But now you're taking this class. You're taking the advanced master keying class. Guess what? We're going to give you a new tool that you can go back to that customer and says, you don't need to buy new hardware. We can come up with a lot more changes, and we can maintain this system for the next 5 years based off of this. 6 different locations, 6 different buildings, 10 different locations. We can do that for you. No problem. Okay. Now, who do you think is going to get that bid? You do that math and you times that math for whatever you charge for rekeying and master keying. You just deposited a very nice check in your account when your competitors could not. Okay. So that's how it applies to the real world.
Using an original 5-pin Kwikset system, using the standard Kwikset rules of a max 4 and only 6 different pin sizes, yeah, there's 1,024 available changes, but only a few hundred are viable. The master key cuts in this system are 23214. Only 242, as you can see in the little green circle that say valid, are the changes with that master key. About 24% of the total system. Like you're saying, Wayne, I mean, 242 is squat.
It's nothing. It's nothing. You're going to go through that. You're going to go through that in one rotation. That's months. and you're going to be out of changes.
Right. And if you have, so you go ahead and you have the Knox box each has a different master key in it. Well, the fire department knows that ahead of time. So you only have, one master key that will work in that one building. But again, 242 changes. And if there's 50 units in there, you'll go through that in a matter of maybe 3 months. And then they got to do a total rekey again. That's not going to work out.
No.
Not mathematically, not physics, not practicality.
Yes, it's not practical. So we do have a question in here. Paul Newman has asked, is it best to make the biggest master key system for any given business? I wouldn't pigeonhole myself into any one statement. I would say that it is your responsibility to understand the customer's needs. And based off of the customer's needs, design a system that is going to work best for their needs. If I have a customer, and I do have a client that has 3 buildings, that has 20 tenants in each building, and they're on the KW1 system, right? We can maintain that system, those numbers that we're showing here, that is totally viable to maintain that for a decent amount of time. And I will ask my customer, what is your turnover rate? How often, because this is employee housing, right? There's difference between employee housing and having to rekey campuses, right? We have to understand that. Somebody who's a college, rekeying a campus, you have to rekey that every time you get a new tenant. So you are rekeying every single door every single year. That needs a massive amount of change keys. That customer's demands are totally and completely different from the person who has employee housing, who has a turnover rate of maybe 2 people per month. They will fire and hire 2 different people per month, because in my area here in Colorado, it is insane. It's like California housing prices. If you're an employer, like to work for the state or the city or police departments, they have to provide housing. They have to offer housing, or they wouldn't get anybody to work for them. So those are the systems that we maintain with that. And that's how we maintain it, is what is your usage? What is your turnover rate? And how often are we going to be rekeying these? And how many? That's going to give you a gauge as to how many changes you're going to have over the next decade. Right? That's what I look at it. Look at it as big picture. How many changes do we roughly estimate we're going to need to change over the next decade? And based off of that number, you can do your math to see if the system that you're suggesting is going to meet those needs. A strip mall, those people are signing a contract, they're signing a lease for 2 to 4 years, and they're probably going to be there. And businesses don't like to change. They don't like to move addresses, because then they're going to lose foot traffic, right? If a barber is at that one location, they like to stay there for years and years and years. So you're going to have those businesses that come, the ice cream parlor comes, they go out of business, there's a new coffee shop, there's a new hair groomer, a dog walker, whatever it is. There's going to be some that cycle through, but that strip mall is going to have a fairly low turnover rate in most applications, with my experience. The college campus, the places where there's students, massive turnover, massive amounts of changes. You need a system that's going to run a massive amount of change keys and be able to work with that system long term. Okay, so hopefully that answers your question. It's not always about the biggest. It's about connecting your customer with the correct product and the correct master keying system to maintain them through the next decade. That would be my professional opinion on that. That's how I would handle it. Ready for your next slide?
Is everybody else ready for the next slide? Is the question.
I don't see any questions.
Okay.
So this is our 5-pin Kwikset system, and you can see how dramatic, like how low the numbers are.
And Wayne, I also have to point out, I do not use, in my systems, I do not use a 1 master pin, because the 1 master pin of, I believe it's a 23 thousandths, could get lost or stuck in the plug. So This is based on master pins only of 2 through 5. 2, 3, 4, and 5. 2, 3, 4, 5. Yeah.
We're trying to avoid that. Like, look, do you remember when we started this course, that Defiant lock? Did you see how big it's not even holes drilled. It's a slot all the way through there. Do you see the difference when I was rotating the plug, how sloppy it was? And I'm not trying to beat up on anybody. They have a price point that they're trying to meet. They said that this meets building standard, whatever, UL listing. They met their standards.
Right.
But those standards don't necessarily meet our requirements, trying to do something with that lock that was never intended for it to do. Defiant didn't go out there and say, we're going to build locks that can be master keyed and in these massive systems. No, they didn't do that. So putting those smaller master pins in there, it's better than a 15,000s for a Schlage. 23 is, but it's not ideal. You still want to do that two-step progression. You notice even with the one I did, every single number was more than one number separate from each other. There's at least 2 number variants between each one of those cuts, 1 and 3, and then 4 and 1, right? That's what we did there. That's why I gave that demonstration specifically for that.
Okay. However, by using our hybrid pinning method, Schlage depths with Kwikset spacing, we reserve the number of valid changes versus invalid changes. In this example, using the same master key of 23214, the system produces 819 viable changes. The usable changes percentage increases from about 24% to about 80%. It works out actually to 79.98%, which is a major improvement.
Absolutely. We go back here, 242 valid changes to 819. Massive, massive improvement. So that's why we would say that this is something that we can do. And again, we're taking, if you look in the top of your lab pin kit or whichever pin kit you have or your factory specs, it's going to give you what those factory specs are. We are moving away from that so that we can bend the rules of mathematics and the mechanical operation of something. The spacing still needs to be the same. If you start changing the spacing, you're going to have some major problems. So you can't just take a Kwikset key and just cut it on with Schlage programming. Right? You can't just cut it on a punch or anything else. You need to maintain it. And this is where having certain machines, Jerry's brought a lot of these together and built a lot of these on the Frame number 2, because you can actually dial it into the exact thousands. I've got a Triton. You can dial it in. You can say, I want a Kwikset keyway and I want a Kwikset profile, but here's what you can program the cuts that you want and the depths. So it keeps the manufacturer's spacing in place. When you're doing this, you're not going to be able to flip up that pin chart on your lab pin kit and say a number 1 is this, and a number 2 is this, and a number 3 is this. You're not following the factory guidelines anymore. We're using the Schlage guidelines and the Schlage depths to expand our Kwikset system into something that it was never designed to do, but through intelligent processing and math and the beauty of mathematics, wonderful world of math, we can. It is possible. We can do this. So that is why we're bringing this to you, and hopefully that's explaining it to where you understand exactly where we're coming from on this. Need your next slide?
Yes, sir. What to know about this method? The Kwikset hybrid system is not a replacement for standard Kwikset pinning. It is a specialty method that can be dramatically increased usable changes when properly documented. I can't stress that enough. You have to document what you're doing and how you arrived at this. Careful calculations and used for the right application. The most important takeaway in the documentation: the system must be clearly labeled as a Schlage depth Kwikset spacing hybrid, so that not to mistake for a standard Kwikset system later. especially if someone takes over your system or they call out another locksmith and he looks at that and says, this doesn't make any sense. How is this working? And especially when he looks at the keys, you don't cut the keys any wider. You don't widen the cuts on the Kwikset key to work in this system. You just go ahead and right in the center, you just cut it, you don't widen it, and that's it. Now, there is one caution. The Lishi tool and Kwikset decoder, Lishi tool, will not work to identify the depths of the key. The Lishi tool may open it, or you can probably pick it. But the decode method, decoding the depths, will not work with the Lishi tool. So that's a little caveat you want to take into consideration. Does it prevent, I don't know, Wayne, what do you think?
Well, there's a lot of what we're doing here is we're going off the rails. We're going off of what the manufacturer's specifications are for that. And we're saying, based on the engineering limitations and the mathematical limitations of the factory system, again, this has such a narrow use, but in that one narrow use, you can save your client thousands and tens of thousands of dollars. The one that I just gave, and it's an actual reference to a client of mine, and that we've had to do this. They built 3 different buildings, and they put the cheapest hardware on there possible. And I'm not mentioning brands or names. We're not picking on Kwikset either. We're just saying that's the keyway, because that's a common keyway that a lot of other knockoff companies and hardware manufacturers use. They use the KW1 keyway. So we're not beating up on any one person or any one brand here. We're just utilizing it to its maximum potential. So the problem is that they're going to come to you and they're going to say, we need to master key this. And you're going to say, you don't have enough changes. This hardware isn't compatible. And they're going to say, we don't have it in the budget. We just spent $10 million building these apartments. Our budget is spent. And if you've ever been in construction, it goes over budget and over time every time. Okay. So they've already spent hundreds of thousands and maybe even millions of dollars that they did not intend to spend. If you tell them they need to replace all the hardware, they're going to tell you to show you where the door is. They're going to kick you out of their office. So if you don't know about this, you're the locksmith walking out the door with your tail between your legs, right? And you don't have any money in your bank account right now. If you go into that situation and I walk in there and I say, I see your problem, and I know why that other locksmith told you that, because I'm going to get the phone call. They told us we need to buy all new hardware. What the heck is going on here? We need a second opinion, right? I'm going to be the second opinion. I'm going to be Dr. Locksmith Wayne. You're going to get a second opinion from me, and I'm going to say, is this possible? Yes, it is. We have a mathematical system. We use a program that can break this down, and it's not factory. I'm going to tell you that right up front. The factory says that this is not supposed to work this way. This is non-factory specifications. But mathematically and mechanically, it is absolutely plausible, because the original OEM manufacturer never intended for this hardware to be designed to do what you're trying to do. Therefore, yes, I do have a solution for you, but it is not factory designed or approved. But it's mechanically possible, and we can solve your problem. So they're going to say, buy new hardware for tens of thousands of dollars, or hire this guy to rekey everything using his system and use what we currently have. What do you think they're going to go for? Whether they're going to spend $50,000 to replace the hardware, or they're going to spend $5,000 to set up this master key system. A factor of 10. You tell me what they're going to do when they're already hurting and over budget. They're going to go with the locksmith that can set up the system for $5,000. And I'm just picking random numbers here. Okay. But that's where this is going to come into play. And that's where you can bring it into effect. Okay. That is like the one and only scenario I can think of where that's going to happen. I don't know where else that would even be. Not to mention, most of the new Kwikset hardware is actually the smart key system that doesn't even use pins anyways. Right. So you need to consider that. You show up on site. Hey, we need to master key everything. Oh, this is all Kwikset smart key. You can't do that unless they have the one cylinder that's designed to have an additional master key override, which is a completely separate cylinder. But we're getting a little off track there. I'm going to touch on that, and I'm going to let you know that that might be out there and that situation might happen, but you're going to have to come up with a different solution for that customer. If you show up and it's got other grade hardware with a KW1 keyway, this system can be used to save the day. So they don't have to buy all new hardware. Yep, here we go.
These are the pin sizes used for a Kwikset cylinder applying the Kwikset hybrid method. You notice that the method, in this method, we do not use the 165 or the zero cut bottom pin in a Schlage. The Kwikset key blank sits a little slightly different height than the Schlage key blank, and that small difference can affect smooth operations. A difference of 6 thousandths may be enough to keep the lock from working smoothly. Therefore, eliminating the 165 and renumbering all the numbers now from a 0 of a 180 all the way down to the 315. I added, or you add, the 0.315 to the master key system. Again, a two-step master key system only uses even numbers: 30 for number 2, 60 for number 4, 90 for number 6, and a 120 master pin for number 8. So there's your math. There's everything. And again, with a Schlage system, your max is 7. Will it work? Yes, it will work. I've seen it. I've done it. I've used it. I had one apartment complex that had 3 different buildings. We used 3 different master keys. It didn't go ahead and all the master key, one master key would not work with all the buildings, or they had different areas built, or different complexes built at different times. So each one has its own individual master key, and that is in a group, a cluster of 4 different buildings. They have 12 buildings built overall, and each master key works for 4 buildings. So you have to know which master key to use in that system. Is anybody swimming in questions, Wayne?
Isn't there too much slop in generic Kwikset cylinders to be able to tolerate Schlage depths?
No.
There you go. Good question. Good answer. All right. Do we have any other questions? Pyro Lock was asking that one. So good stuff. Don't leave yet, everybody. We still got some pretty cool stuff to go over here based off of what we just talked about. Okay. We are taking a Kwikset lock and we are applying Schlage mathematics and depths and pinning. We are going to expand on that a little bit more, and that is going to be what the System 70 logic is going to be. I'll let you go ahead and start explaining that, and if any questions come up, we will answer them as we go. But I will tell you, keep in mind what we just talked about, and that is going to apply here. We're going to take Schlage that already has a lot of options, and we're going to expand that even more using another set of mathematical principles to expand your Schlage system. So just like we took Kwikset and we took it from 242 options up to 800 plus, we're going to do the exact same thing for Schlage using this 70 system. Go ahead, Jerry.
System 70, we all have heard of Corbin Russwin System 70. Any locksmith that's been in the field for maybe a year or two has run into a System 70 system. If you think about it, you're saying, well, they only use 6 different pin sizes and they only use 6 different depths and everything. How is that possible? How do you get so many changes? Well, in a System 70 system, the parity goes out the door. 1 plus 1, you have a 1 cut now, a 1 master pin. You have a 2 master pin, a 3 master pin, 4 master pin, and a 5 master pin. You only have 6 depths in a system 70. Can I have the next slide, please? In a 2-step system, this is a Corbin Russwin 2-step system, the pinning sizes. You see that there's a 171 bottom pin of a 171. Coincidentally, that's the same size as a Kwikset. Then you have the 186, the 198, 213, and so on. The 2-step logic, again, we will not use the 3, 5, 7, or 9. We only use the even numbers. So again, we're going to get with 4,096 different changes in a 6-pin system. I didn't do the math for a 7-pin, sorry. But Corbin Russwin 2-step will have 4,096 changes. Does everybody understand?
No questions so far. That's actually, while we're on that point, Jerry, I want to go ahead and just go ahead and expand that a little bit. When we were talking about those multiplex systems, you did see on there that there were some Sargent options that did have a 5, 6, and even 7-pin option. So those are out there. Again, boy, if you are getting that deep in the weeds, you need to contact myself or Jerry and really understand how that system's going to be built or how to take it over. And you're going to need something custom. You're going to need some kind of custom software to be able to maintain those systems and understand them, because it's going to break your brain. It's going to break you. You know, there's just so much that has to go into that. But I wanted to touch on that because we did talk about some keys do have a 7-pin system, and that extra pin obviously allows for more changes and on and on and on, and the same things that we've repeated several times throughout this process. I just wanted to touch on it, let people know it's there. It's there. We touched on it. If you're going to dive that deep into it, you want to back it up with a little bit more education and learn a little bit more about that system before you jump in both feet on that one.
Okay. In a single-step system, notice the difference, 2-step versus single-step. Single-step, we do not skip around. But we don't use the master pins. Let me read the highlights better. Bottom pins are renumbered. We renumber the pins from 1 to 6. So 171 is a number 1 pin. A 198, though, is a number 3 pin. A 228 is a number 5 pin. So you see how we're using larger increments of pin sizes to accommodate a single-step system so that the pins don't get trapped and the cylinders work properly. A number 5 master pin is the largest master pin needed because a 1 cut plus a 5 master pin equals a 6 cut. There's nothing deeper than a 6th cut in a system 70 system. Corbin doesn't have anything deeper. There's no deeper cut than 6 in a system 70 master key system.
Right. And so to tie this together, again, you need to break what you normally think of when you're thinking of rekeying and master keying. You are not flipping up, just like we explained for Kwikset. I want to tie that right into this. Just like we're using Schlage depths and master pinning rules on a Kwikset system to increase the amount of changes possible. That is why we're doing it. Okay. So again, this scenario will probably be more popular than the Kwikset scenario. The Kwikset scenario is very, very narrow, right? That's a very narrow. The apartment complex is the only thing I've ever even heard or could even conceive why that would happen or need to happen. Okay. This system is the same exact function. Let's say we have a person, investment company that owns several strip malls. Okay. Not just one, but several throughout the state or even across multiple states. And again, we're going to go through this scenario because I'm going to tie what we're learning into applying it to a real world application. Now, what do we know about strip malls? They're going to have an aluminum storefront door. They're probably going to have the crappy cylinders that came from the door manufacturer that are going to have low tolerances, that are going to be a little sloppy. They're pot aluminum. You guys know exactly what we're talking about. We've all rekeyed these thousands of times. Okay. That system is already going to be in place. And guess what? It's a 1-inch cylinder with a 5-pin key. So our options are high client. They're going to come in and they're going to say, we've got 20 different locations. We're going to use different numbers now. We have 20 locations across the state, and each one of those locations has 70 different individual tenants that we need to create a key system for. I want one key that's going to operate all of my units at any location at any time whatsoever. One key. So when I drive around to go do all my checks, I can make sure that we have a key for that. Each individual building is going to need a master key that opens that building, but on another one. So page master, right? And then we've got maintenance people who are going to need to get to certain locations, janitorial, bathrooms, etc., those places within there. Can you build this system and can you maintain this system? Locksmith A is going to say, we don't have a big enough system. You have a 5-pin Schlage system and you're going to run out of change keys too quickly, right? A year, 6 months, and you're going to run through 800 changes or 1,000 changes and you're going to be done. We can't maintain that system. That's Locksmith A. So Locksmith A is going to say, you need to buy all new cylinders. We'll order all new cylinders. You do your math on 20 locations, 70 different tenants in each one. You tell me what that number is. It's a big number. It's a bigger number than just master keying what they have. Option B is, so they tell him, hit the road. We're not going to spend, $100,000 rekeying and redoing all the hardware on all this, right? We're not going to do that. They don't have the budget for that. So they're going to get a second opinion, and they're going to call me or they're going to call Jerry, and they're going to say, hey, same scenario, 20 different locations, strip malls across the state, 70 different tenants in each building. This is what we want to do. We have new math. We have advanced math. We have math that is going to push the mechanical ability to the very limits of what is possible, not what the manufacturer spec'd, what is mathematically and mechanically possible without compromising the system. Okay. And so all of this math has been double checked and all of it checks out. It's been ran through processes and computers and everything else so that it works. We know that the system works. So now I say, cool, I can do this for $20,000, $25,000. Whose bid are they going to take? Are they going to take the $100,000 bid and replace all the hardware and all the cylinders to get them up to a 6-pin cylinder to be able to maintain that? Or are they going to take my bid that's going to work with what they have and not have to replace everything? You tell me, right? Now, even I would suggest, and I'm not just going to say, hey, we should run this on this 5-pin system and do that. I would say, ideally, we'd jump up to a all brass cylinder, a 6-pin key, an 1.125" cylinder instead of the simple inch cylinder. But that's going to be the best way to go, right? That's ideal. But they don't have the budget to do that. So I'm going to either get told to hit the road and they're going to shut the door on me and they're going to go to the next one until they get the answer that they want that meets their needs. When they get the person that meets their needs, yes, I can do that. It's $25,000. I need 50% deposit up front, and we'll go ahead and get started with this project for you on Monday. That's what they want to hear. Now that's my customer, and that $25,000 is in my bank account and not my competitors, because we have a new understanding of expanded math that will work, not in theory, that is functional and will work without getting pins trapped and without compromising the system. You can maintain it all throughout the entire service history of that system. You can maintain it long-term. And that's what we're trying to get across here. That's why we're doing it. Okay. That's how it works in the real world. That's why we would do this. Same thing, again, happens to an apartment complex. You got 5-pin commercial grade Schlage locks with Schlage keyway. Same concept applies. It's going to work in that application for the apartment complex, the strip mall, the commercial building, whatever it is, it's going to work in all of those applications. So this is what we just did with Kwikset, zoomed out, expanded, larger capacity. Okay.
Hang on 1 second, Wayne. I got to do one more thing here.
Okay.
You said 5, so I. Okay. So we see here how this is going to work out with the Corbin system. But Corbin doesn't have a lock on System 70, does it, Wayne?
Not that I'm aware of.
Nobody has a lock. I mean, patents last for 17 years, if I remember correctly. And, well, Corbin's been around a little longer than 17 years, I do believe. So that's where we are with that. Next slide, please. So we're going to apply System 70 logic, the methodology, to with other manufacturers' depths. I hope everyone's sitting down. I hope they're all paying attention. Next slide, please. Applying System 70 logic to Schlage depths. Using Wayne's example, a 5-pin system, you'll have roughly 1,024 changes. But using the System 70 Schlage keyway, or the System 70 Schlage process, and only 1,024 possible changes, you'll end up with 3,125 possible changes. Your valid cuts are 1,586 possible viable changes.
Beautiful.
Any questions?
Let's check our questions here. I don't see any questions yet. We haven't broke their brains yet.
Yeah, that's good. Okay. This chart shows the pin sizes. Very important. The pin sizes used to pin a Schlage System 70 style cylinder. Remember, the working max is reduced to a 3 because we doubled the size of pins we use. Doubled the size of pin sizes we use. Therefore, we have to reduce the max.
Right.
Does that make sense? Schlage System 70 in a 6-pin using that we use in the advanced master key. We know there's this one here, the cuts of 201,375 only produce 2,835 changes. However, a System 70 single-step workbook with a master key of 252525 gives you more changes, but also more invalid changes. Your changes went from 2,800 to 7,200.
Yes. So again, 4,000 with the typical system with that master key, that TMK that we talked about,
Right.
201,375. And we're going to give you a demonstration. So we're going to use that big cutaway cylinder. We're going to bring that back up and we're going to show the System 70 working in that application and how it works. Now you notice when we go back to those pictures here, when we go back to this system right here, that top key, or the number 1 master pin that's going to go on the top, is a 30 thousandths, which is compliant with our standard rules, right? That means we're not doing single step to where we're putting smaller pins in there. We're making the minimum baseline of 30 thousandths. So when you're doing your two-step Schlage, 30 thousandths is the minimum, a number 2 cut, same principle and rules apply here. We're just utilizing different math for the rest of the pins because it'll expand our system. It'll give us a larger expansion. So that way, when you talk to your client who's got, this many 70 locations at 10 different locations or 20 different locations with 70 different tenants across the state, you can still maintain that system here. Okay, we can still do that. So I'm gonna pull that video up here and we'll go ahead and watch that and we'll see exactly how that works in HD. Schlage System 70. Okay, hopefully you can see. Alrighty, so we are going to set up our 70 system here, and we'll just go ahead and put these. Another real key factor to master keying. Notice how clean my pinning area is. Where my work zone is, I've got the exact pins in the exact location where they're going to go. This is chamber number 1, cut number 1, cut number 2, cut number 3, cut number 4, cut number 5, cut number 6, with all the bottom pins in place and the top pins right above them. So I can see exactly what we're doing. I don't have a bunch of pins rolling around all over the place. You got the detent and a detent spring hanging out over here and the 4 keys that we're going to make work with this system right there. Those are all the things that are on here. Now we were going to do this on a Primus key, but things got a little complex and a little complicated and they didn't work out. But the main thing is keep your pinning area nice and clean while you're doing master keying. It will make your job and your life easier.
Place. Where did my... So we're going to start off now. Remember, with System 70, we are utilizing non-factory Schlage numbers. Okay, so this is going to be a 195 that goes in as the bottom pin here. We can zoom in on that a little bit. Okay, so we're going to go 195 bottom, 0.60 top. Yep. Come on, go in there. All right. And then 165 bottom, 120 top. One 95 bottom, 30 top, so that we do not violate going less than 30 thousandths. 285 bottom, 30 top, 195 bottom, 30 top, and 285 bottom, 30 top. Okay, so that is exactly what it's going to look like in the actual plug itself. Okay, let's back that off a little bit. We're going to go ahead and put that directly into our plug here, and click. All right, so now we have our TMK, right? And that's going to work just like that. So there's TMK. Then we have our Blockmaster, okay? Just like that. Blockmaster, Groupmaster, working like so.
And again, these cuts are not conventional Schlage cuts. So you have to follow the chart. And then here's our change key. Okay, change key, perfectly working fine. And there you have it. Now we have all of those systems working right here. And you can see how it works with that cutaway cylinder. And then we would just simply screw this back on, just like normal. And now we can see how that System 70 can work with a Schlage system. Okay, we're just doing different math with the equations that are provided. There you have it. TMK, Blockmaster, Group Master, and change key. Beautiful. Thing of beauty. Awesome stuff. And this is going to give you a tremendous amount of additional change keys compared to the regular two-step system. That's why this is valuable.
So basically, we're cheating the system.
Right. We're expanding.
We're expanding from a two-step to a single step, but we're getting far more viable changes.
Should have used this a year ago.
Well,
yes. Well, you got it now. All right.
Now this will go ahead. You cannot, and there's a caveat here. You have to go ahead and you cannot adopt this into a
existing system.
Existing system. Thank you. It has to go ahead and you have to start fresh. But this will go ahead and not only will it knock the socks off of your competitor, if your competitor doesn't know about it, share it. Yeah, share it. Don't be the sole keeper of the knowledge. Always share knowledge. That's what I love. That's what I love doing, is sharing knowledge. And this is something that I've seen before. I ran across it in when I owned my own shop. I mean, I was at one place and they had Schlage, and I'm going, why is everything so weird? And I was trying to go ahead and pin everything up the way they had it, and I didn't know anything about the System 70 at the time. And I thought, why is this way? Then all of a sudden it dawned on me, this is why. Yeah, it's like a little emoji with a boom.
Yeah.
So
pretty cool stuff. You ready for your next slide?
Yes, sir. Schlage System 70 versus two-step versus System 70 comparison. You see side by side. 2,835 versus 7,292. Roughly a 2-to-1, 3-to-1 ratio.
Yeah, lots more changes, lots more options, expanding the system without having to go into something. So that this is, where are we going to use this? All right. Well, even if we take a 6-pin system, a 6-pin Schlage system, and we say, all right, this is how many buildings we need to do. This is how many tenants we have. And that number's too close. And you say, well, now we need to change hardware. We need to go back to Multiplex. And you need to get Schlage SE8s and SE9s and SE7s. We're still replacing hardware, right? Apply this to the real world. How does this really solve a problem? Go to your client, Locksmith A. You got to get SC7, 8, and 9 cylinders. We can do this. We can get you, we can get you your SC15 or your SC20 as your TMK. That's going to open up all the buildings, but we're going to have to replace cylinders on all the buildings. Or we don't have to replace all of those cylinders, and we can run different math that can expand that system and make it almost 3 times what we could do before. What option do you think we're going to go with? Or what option do you think your client is going to go with? And you present them with both options. we could send this to a high security system. We could make this, Medico, or we could make this, a multiplex system or a multi-tier system using any of the manufacturers, Schlage, Sargent, Yale, whoever, Corbin, whoever, based on the hardware that's going to apply, that's going to interact or engage with that, with cylinders, right? Or we can do it based off of math, and we can do it based off of this system, and we can expand that system and save them a ludicrous amount of money while doing so. Now, that doesn't mean that setting them up on a multiplex would not be a better option. That could be a better option. But if they're not, you can't force them to pay it. You can't pry their wallet out of their hands. You can't. I've tried, and they held on to it pretty tight, right? So you can't pry the wallet out of their hands. You can only lead the horse to water, and you can only present them with options. If I'm the locksmith that has more options, and I can meet their price point, there's two things or three things that most customers take into account: price, availability and ease of use, or an easy button, and service. Well, if you provide good service, that's great. If you can make an easy button, which this system is doing, that's going to give you an advantage over your other competitors. And then price. I can hit a better price point. I can keep this, instead of 100,000, we're doing 10,000. Instead of buying all that hardware, we can do it with what you have, and we can do it now. Time frame might be an aspect of it. We just fired our other locksmith. This system is trashed, right? It is completely compromised. It's not been taken care of. It's not been maintained. We've got students coming in, or tenants coming in 2 months. Who can get it done with what we have? We don't have time to order new hardware. It's not going to come from the factory in time. Whatever it is, that's going to happen. Okay. So good stuff there. Let's jump on to our next slide.
Even though Schlage System 70 style chart only uses 6 steps, the math works in our favor. Standard Schlage 2-step system, 2835 valid changes out of 4,096 possible combinations with a max of 7. Schlage System 70 system configuration, 7,292 valid changes out of 15,625 possible combinations with a max of 3. The larger depth separation in the pin sizes creates more usable combinations. The working max is reduced to keep the system practical and reliable. Even after reducing the max, the System 70 configuration still produces far more valid changes. Fewer depths, more usable changes. System 70 uses fewer depths, but larger 30,000 separation. I've got to drive this home. I spoke to someone last night that couldn't understand this for a second. Then I could almost see the light bulb coming on above his head when he saw this. This allows us to use every single step progression. So we don't end up with 4,096. We end up with 15,625. The larger separation between pin sizes creates more usable changes than the standard 15,000 step system, which is our Schlage two-step system. Applying System 7 logic to other manufacturers. Arrow has a max of 7, so we would go ahead and 7 divided by 2 is 3.5. Well, we would mark it down to 3. Schlage, we know, is a 7, and we've marked that down to a 3. Sargent, like Corbin Russwin, the max violations are an 8. Therefore, we divide that by 2, and we'll get far more viable changes with the Sargent system. So getting back to the, you could do the System 70 system, a Sargent System 70 system with the multiplex keys. you could end up with thousands and thousands and thousands of keys.
Yeah, we're getting pretty heavy and complex on that. That would be
Yes.
that would definitely be something. Hey, you would probably want to call and talk to Jerry and talk to him about that and make sure that you understand that system fully before doing it. But it's mathematically plausible or possible. It's possible to be able to do that.
Now, one important caution: do not assume every TMK bidding will produce the same number of viable changes. That's with a two-step system, and that's also with the single-step system. Some will give you more, some will give you less viable changes. Always verify the system before you build the final keying schedule. And I mean verify, I mean look at it, look at the math. If you got to print out 64 pages, print out 64 pages. Make sure everything is going to work in your favor.
Cool.
Okay, this is the fun one.
Yeah, so we've got a little fun stuff here. This was actually, so I had heard about this. John Hubel is with the education department for Aloha, and I had overheard him talking about this, and I was trying to think about exactly what it was, how it was mechanically possible, and why you would want to use it. So why would you want a one-way lock? Why would you want a one-way key? Well, let's say you have a tenant or employees that can only that you have a very high turnover rate, right? Like here in Colorado, we have dispensaries, right? Dispensaries have a very high turnover rate. There's lots of people cycling through there, and maybe they want, like, the manager is going to be at the morning shift and the non-manager is going to be closing. Right, they're going to be closing the facility. Now they've got cameras; they can watch and see everything while they're there, so they're not stealing money. But this comes into a trust issue. So, what if I told you, or what if you were the customer and I told my customer, "Hey, I've got a system to where you can give your manager a key that locks and unlocks the lock, like any other key and lock in the whole entire world. One key locks and unlocks; it does both. Right? That's what we're all familiar with. But then you had your less trustworthy customers who needed to lock up at lunchtime or lock up for closing. Well, your higher end manager, he's earned the privilege of not having to close the location at midnight, right? And so now you can give this lower level employee a key that will only lock the lock. They can't come back and unlock it and steal things, right? That's what we're getting at here. They can't come back as unauthorized and come back and do something that they're not supposed to be doing. So there is a way to do that. And when John was talking about this, when John Hubel was talking about this, I was like, I got to play with that. I got to try that. And I got to see exactly how this system works and what exactly is going on here. What kind of wizardry are we talking about? And so that's when we came up with, or he came up with this, and who knows where he got it from. I don't even know. But this is what we came up with here. So this will work for a deadbolt or an Adams Right deadbolt as well. This would not be, I want to clarify, this would not be a viable solution for a lever where you've got to turn, you've got a lever lock, right? It's not going to work for that. Okay, maybe you could come up with something where you've got classroom and non-classroom function. I'm not going to get that deep into it, but a simple deadbolt, whether it's a conventional deadbolt like we're going to watch here, or a deadbolt like an Adams Right deadbolt, where it turns one way or turns the other way, turn one way to lock, turn the other way to unlock. This will do that. And I just wanted to make it part of this because sometimes you just like seeing cool stuff that you haven't seen before, and this is one of those occasions. All right, we're going to be working on a one-way key, and I'm going to show you how that works using this cutaway cylinder here. So you can see that bottom pin. Normally, this is what your cylinder would look like. The key is inserted, and all of the pins are at the shear line here. So why would you want to use a one-way key? Well, let's say that you own a business, and at that business, you would like to hand out keys, but you don't want to hand out keys that unlock your business. You only want to hand out keys that they can use to lock the business. This would indicate that you want to maintain a level of security so that if you have a high turnover rate, these people can come and go and you can hand out that key without having to rekey the facility, because if they can only lock it, who cares if they have a key? They can't unlock it. So this is a way to mechanically control the entry of the location. And we're going to do that. I'm going to go ahead and I'm going to tell you we're using a 6-pin lock here. And the reason that we're using this 6-pin lock is because we are going to file one of these cylinders down, or we're going to cut this chamber down just a little bit to accommodate this number 4 master pin here. And that's how this system is going to work. And the reason we're using a 6-pin system is because I know the first thing people are going to say is the number 1 rule of being a locksmith is you don't file the cylinders down, right? We don't file the cylinders because that reduces the security and it ruins the cylinder. And we're taught that from the moment we start doing our locksmith job. However, in this case, normally that would be a 5-pin key anyways. Right? So if we take into account that we're adding the extra pin for security in a 6-pin system, and we're only going to compromise one of those chambers simply to accomplish the goal that we're trying to accomplish here, which is a one-way cylinder, then you maintain the security of the other 5 pins as though you had a regular 5-pin lock, which most storefront Adams Rite doors are. Morta cylinders like this are only going to be 5-pin anyways, and most deadbolts are going to be, a residential deadbolt is only going to be 5 pins anyway. So we're adding the 6th pin with the intention of making it mechanically work the way that we want it to work here. So I'm addressing that issue from the get-go, and I'm telling you why it's going to work this way. Now, anytime we master key a lock, we're taking security out of the lock anyways. We're allowing more combinations to work, and we're allowing multiple shear lines and multiple keys to work. So you're already destructing the security of that cylinder by doing the master key system, and people need to understand that. So once we understand that, we're going to be able to show you how this works, because it's kind of a cool little trick. Okay, so this would be a great solution for, let's say, if we had a customer who, again, like a check cashing place or a fast food restaurant or somewhere where there's a lot of turnover, a high volume of turnover. Okay, that is where this is going to come into play the most. So I'm going to take this key. This would be the average key that comes with your cylinder. We're going to take that out of the equation because it's not going to matter anymore. And we're going to say that this is the key, and it's cut to 226622. And then on this key, we're cut to 226626. Okay, so this is going to be our one-way key. And the way that we're going to accomplish that is we're going to dump these pins out, and we're actually going to shave this cylinder down on only one side. Okay, I want to reiterate that, on only one side. So that means that it's going to be shaved down on one side going towards the opening, or I'm sorry, the locking way of the lock. So actually we're going to have to shave it down on this side. Okay, so if we're going to have a deadbolt, depending on which way the deadbolt is mounted, I guess we could do it on either side. So if we do it on this side, then the deadbolt would have to be thrown and locked this way, because this is the side that we're going to shave that cylinder down on. Okay, so it will allow this pin to get trapped in there, but only one way. Only one way. It's going to be a one-way lock cylinder here. Okay, so I'm going to back that up a little bit, and then we'll just go ahead and pin these up. I'm going to pin this one up to our standard key here. So we've got 2, 2. Two,
And I just picked easy numbers for easy math. Okay, you could do this with whatever combination you want to do here. So then we'll do a 6, a 255, 2 of those. Okay. Okay, so we've got our operating key, as you can see here. Okay, and everything is nice and flush and flat. Okay, but what we're going to do is we're going to put this key in, and now this key is cut to 226624. Now, if we were doing normal master keying, we would put our number 4 master wafer there, and you'd be able to turn it both ways, right? But that's not what we want here, okay? That's not what we want. We want for this to turn one way, but not the other way. So what's going to happen is that driver pin is going to sit down in there, and it's going to go one way. It's going to block the shear line, and the other way, it's going to allow it to pass. So I'm going to show you how that's going to work, okay? And I'm going to give a rough indication that we're going to need to shave down to about here, okay? So we're going to take this cylinder, and I'm going to mark this off, and I'm going to do this to about there, okay? And that way, you'll have a one-way shear line. I'm going to take this out so everything drops. So I've got a carbide burr on here. This is a tile cutting bit. This is also the same bit that I use to drill high security cylinders, because the carbide will cut through any of the hardened steel. Okay, let's take a look-see. Turn this on. Okay. And now we'll smooth it out with our file here. Be able to get a whole lot on there. But hopefully you can see what we're going for. Now, when we put this key in, I'm going to have to go down just a little bit more. Okay. All right, let's see what that does. And there we have it. Okay, now we know that when that driver pin is sitting down in there, like so, it will be allowed to freely move and pass
through to this side. It's a really good picture. Okay. So now, when we put this back together, okay. Ha 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 ha. Beautiful. Okay. So see how that works? You can see the cylinder and how that top pin is being driven down in, but it can only turn one way. I cannot turn the other way. I can only turn the way that it needs to go. The key that is the locking only key has a deeper cut. Therefore, you can't take the key and file it down anymore. You will just file it down to where it does not work at all, and then it doesn't do anything, right? And they don't know which chamber it is. Now they could take it apart and they might be able to figure it out, but by that point they're going to have more information anyways, and they're going to be able to get around it that way. But for the most part, you can't just take that key and then file it down because it's got the lower cut in it already. The key that has the higher level of security, which is the whole theme of this entire presentation, the higher level security key, is the one you'd have to add material in order to do that, which was not possible right now. And then we'll go ahead and show this one. So that's what it looks like with the key that operates both ways. You can see. Okay, so that one will turn both ways. And then this one will only turn one way. Okay, only turns that way. Pretty cool stuff. All right, so now we'll put this all together and I'll show you how that works in an actual deadbolt. Okay, so we're going to take the cylinder out of here. And I'm going to borrow the tailpiece just because we already have the other one set up. Okay, so I'm going to borrow the tailpiece out of this one. I'm going to pop it into this one. I'm going to put the detent spring back in. I'm going to put the detent tool back in, or the detent back in. I'm going to put that cap on there. So this will be what allows it to operate like a deadbolt.
We'll just go ahead and speed things up, and we're using our cylinder, making sure that everything's working and both keys are working fine. Then we're going to install that into the deadbolt housing. So if you're doing this on a Adams Rite storefront deadbolt, you're going to want to go ahead and change it over to an 1 1/8" or a 6-pin cylinder so that you can accommodate this as well. That would be for Adams Rite storefront, and this would be for a conventional deadbolt here. Notice we have the commercial grade deadbolt, and we're putting the 6-pin cylinder into that deadbolt so that it's going to operate off of that 6-pin system to provide as much security as possible. Typical deadbolt installation: put your bolt in, time the tailpiece, put the thumb turn on, install your screws, screw everything down. Typical deadbolt, working as it normally would until we have our extra little magic key. Just go ahead and make sure everything's nice and tight. Make sure that the thumb turn operates correctly. Looks like we got to cinch this screw down just a little bit more so that it lays flat. And now we insert our key that will both lock and unlock it. So that is our fully operational operating key. And then we've got our locking only key. Notice it will throw the bolt, and then when it's retracted back, it will not turn the other way. You can push, you can even gain extra leverage, but the key will quite literally break before it turns, because that driver pin is driving down into the cylinder on the portion that has not been shaved down to allow the one-way key to work. And then here is our one-way key again, and you can take a look at those. Also, the one-way key is the one with the deeper cut. Therefore, that means that you couldn't take the one-way key and file it down to make it the operating key to operate both ways. You can't add material to the key, and you'd also have to have special knowledge as to which chamber this was done to. It doesn't always have to be the last one, could be any one of them in there. And unless you took the lock apart, you wouldn't know which one it is or how to do that. So, pretty cool little trick playing with the mechanics of how the locking system actually works. Thanks for watching. Take care. And always make sure that you notify your customer and let them know exactly what you're doing, how you're doing it, and why you're doing it this way. Thanks for watching.
Hopefully it shows you and gives you a really cool understanding as to what exactly is going on there. Again, just one of those weird things where you might have one or two clients that might need that application done for them in certain aspects. But the more important thing is you're coming here and you're learning, okay? I've learned things from Jerry. I've never heard or seen this System 70 applied to other manufacturers. And that's a new concept for me. And some people, he hadn't seen this one-way cylinder done before. So we're both learning from each other all the time. And that's what we're bringing to you. So now we're going to take our combined knowledge, right? I've got a decade and a half. Jerry's got 4 decades. We're going to take that and we're going to take that experience and we're going to compress it into 4 hours, and we're going to give you an experience and make sure you're seeing something that's engaging and entertaining. I want every single person to learn something new by taking this course, whether you've done this for 1 year or 50 years. If you come here, you should see or hear one thing that you may not have heard or seen before. And that's what I consider a successful class, is if you learn something new. Every single person here, whether you're live or watching this as a recording, I want you to learn something new. I want you to see something you haven't seen before. Because if we see something we've already learned before, it's not very engaging. It's not exciting. I'm bored. I could go be out making money. I could be running service calls. And again, I want to thank you for your time, because I know that's your most valuable asset and you're choosing to spend it with us. So we'll go ahead and work through the last of this and go ahead and take over for the last couple slides here, Jerry.
What we're about to cover is not the norm. Many locksmiths will frown upon the concept, but in the right solution, it can serve a practical purpose for certain clients. Example, liquor store. I didn't think of dispensaries. The owner opens the store each morning. Employees close the store at midnight. The owner wants employees to be able to lock the door when they leave, but not unlock it later if they want to come back in and do bad things. I can't read the bottom slide.
For example, this will use a 6-pin deadbolt cylinder.
Right.
Yeah, we've got high turnover and high weekly rekeys is not practical.
Correct. Before modifying the plug, we create a one-way cylinder. We only modify one chamber in the plug. The goal is to allow the plug to rotate in the one direction only for that key. Before filing anything, we must determine which way the door is handed, which direction the plug turns to throw the deadbolt, and which direction the plug turns to retract the deadbolt. Let you know the locking direction. The plug is filed only on the side of that chamber. That makes the key able to lock the door, but not unlock it. Modify using a number 4 Schlage master pin as a guide to determine how much material to remove from the 6th chamber of the plug. Follow only the side that allows the plug to rotate to the locking direction. Modify the cylinder as Wayne showed in the video, and it shows how the driver pin, or the top pin from the cylinder, or from the Bible, will not allow it to turn to the unlock position. The owner's key, fully operational, locks and unlocks. The employee's key, deeper cut. The employee's key can be duplicated, but the duplicate will still only perform the same limited function. It can lock the deadbolt, but it cannot unlock it. If the employee leaves, you should key, but the owner does not have to worry about the key that's being used to re-enter the store. We all know it's only going to work one way.
Yep, they can lock it up, but they can't get in. So.
Right. We created a controlled one-way cylinder. The employee's key may be used to lock the deadbolt, but it cannot be used to unlock the deadbolt. The owner's key will still operate the cylinder normally and can lock and unlock the door. Important points to explain to the owner. The cylinder has been intentionally modified and must be clearly documented. Document everything you do, folks. The employee key is for locking only, and a duplicate of the employee's key will perform the same limited function of locking it. The owner's key should be kept separate and controlled. Any future locksmith must be told this is a one-way modified cylinder. This is not a substitute for a proper access control system. This is only used in a very special situation for a very specific situation. Thanks for attending today's class. We covered a lot of material, and we hope you found it useful. If you have any questions, please contact Wayne or Jerry at the emails below.
All righty. I'll leave that up here just for another second. My email, tricountylocksmithservice@gmail.com. Jerry's email, jerry@masterkeymanager.com. Really cool stuff that we've gone over today. And again, when you apply the concept to the correct application, that's where these options have benefit. Okay. You're not that system isn't a form of access control, like Jerry explained. We have a lot of different ways to do that now. Again, does it meet the customer's budget? If the customer says, hey, this is what I'm trying to accomplish, can you do that? Yes, we can. We can do it for this much to give you a mechanical option, or we could install a mechanical deadbolt for this much, right? And if they don't have the budget, then you got to work within the confines of their budget and their end goal, what they're trying to accomplish in the end, right? If that saves them having to rekey every 2 months or every month or every 3 weeks, then you've met the mission, right? And we've told them, we've explained to them, we've gone and expanded their 5-pin key and maintained all 5 pins of security by adding the additional one. So technically, it's actually even more secure than it was originally, even with the plug modified, okay? But then, I wouldn't take a 5-pin plug and do that and then reduce it down to 4. That would be a no-no. That would be not something you'd want to do, okay? But what we want to do here is we're pushing the limits of what is physically, mechanically possible based on the mechanics and the mathematics. And that's what we've done here today. So a lot of unconventional things, a lot of new ideas on how to expand systems. And most importantly, what I feel is most important, how and when do we apply that in our trade to the customers that need that service? And how do we identify that as a need? Again, working with your client, it took 15 to 20 minutes to understand you want 3 locks to work with 1 key, and that 1 lock owner's closet to work with these 3 keys, but these 3 keys did not work with that lock. 15 to 20 minutes of explaining and language barrier to try and understand what they want. It takes time to make sure you do that. But once I understood it, Now I can serve them, and now they get the end result that they wanted. That is my job as a professional. Okay, that's what we're trying to do here. So again, I want to thank everybody for your time. And we're not done yet. I've even got more systems, cutaway cylinders for Primus and Medico. Okay, that's going to be for the next class, for the high security class. Okay, when we say that master keying is the utter destruction of security, it is. You're adding a bunch of different shear lines. You're adding a bunch of different options to that system. And that's what we talked about today. And these are open systems. These are Schlage and Kwikset and common keyways, Arrow, Sargent. These are common keyways that there are leashy tools for. There are picking tools. There are key blanks that are available at a hardware store. Okay. If you want to maintain real security and have the benefits of all of these different keys and master key systems working, that's when we're going to jump up to the high security options. That's when we have a secondary shear line. Primus uses the sidebar and the finger pins on the side. Medico uses rotating pins. There's a bunch of different ones. Multi-lock uses pin-in-pin technology. There's a lot of different options out there that are going to maintain that security option that there's not leashy tools for, that there's not picking options for. I'm not going to say that they're pick proof, because somebody will post a video of a Medico that somebody picked or whatever. I know there's lots of videos, lock picking lawyers out there. I know, I hear you. I already know. But for the most part, those people have intimate knowledge of that lock. They've taken the lock apart and they've picked that lock tens or hundreds of times before they made that little 3-minute video that you watched and think that it's so easy to do. Have them go out into the field and go into the real world and do it with a lock that's been on a building for 20 years. Completely different scenario, right? Completely different scenario. So we're trying to give you information that you can then determine and apply to the customer's needs, where it fits. Where does this fit? And then service that customer and meet their needs ethically, professionally, and responsibly. Jerry, do you have any final thoughts or message to everybody out there?
Oh, Wayne, like I said, I love helping. If anybody has any questions, please feel free to reach out to me. I'm happy to help.
And I hope we have delivered value to you so that you can apply that to your business, your trade, your industry, and you can provide for your families. That's why we're doing this. Have a wonderful day, everybody. Thank you.
Bye.